Welcome friends. Are you able to hear my sound? If you are able to hear my sound, please respond in the comment section. Good morning, good morning. Are you able to hear my sound? Yes, okay, so we are good to go then. There were some problems, but our technical team has taken care of it as always. So welcome everyone to this session on reinforced cement concrete, and in short we can say RCC. Yes. So sorry for the minor delay. Okay. Okay. So let us start the session without any further delay. My name is Satyajeet Sir. Many of you might be knowing me. Yes. Okay. Great. Okay. Great. Okay. So everyone, just first of all, warm welcome. Good morning. Yes. To this, we can say Tuesday, right? So warm Tuesday to everyone. Hope all of you are doing the things nicely. Yes. So let us start the session without any further delay. Okay. So first of all, some announcements. Okay. So those who are aspiring for ESC examination, okay. So Ashutosh sir will be taking a session today only. Okay, 17th January. So today morning we have marathon. You can study nicely, and evening you can attend this session at 7:30 p.m. This will be on the BYJU'S Exam Prep app. This will be on the app. Okay. And then we have another wonderful session coming up. So those students who have worry of engineering mathematics, okay, engineering mathematics comprises of 13 marks. Yes. So if you want to get full marks in this particular mathematics, so both Ankit Joshi sir and Talreja sir will be taking a marathon, but that marathon will not be on the YouTube channel. It will be on the BYJU'S Exam Prep app. It will be what? In the BYJU'S Exam Prep app. Okay. So I'll request everyone 21st January. Okay. See, if you have completed mathematics, this will act as what? As revision. If you have left some portions, then you can complete those portions. And if you have completed very nicely, it will act as fast revision, right? Or if you have not started some topics, so those topics also you can complete in this particular marathon series. Okay. So 21st and 22nd morning 10 a.m. as always we conduct in the morning, okay, marathon sessions. So I request everyone, this will be in the BYJU'S Exam Prep app. It's already written here. I'll write down app. Okay, so I'll request all the students who already have downloaded the app, very good. If you have not downloaded the app, download in the Play Store, BYJU'S Exam Prep app, yes, and then you can access this particular session live when? On 21st and 22nd, means after 4 days. Okay. Great then. So my name is Satyajeet Sir. You might be knowing about me. If you don't know, you can just go through it in a fast manner. So let us start the session today. Okay. So first we'll start the session with question actually. Okay. We'll start the session with question. Now first of all, the most important portion for your GATE examination as far as RCC is concerned will be singly reinforced beams. Will be what? Singly reinforced beams. Okay. So singly reinforced beam is going to be very important. So I'll be spending around 1 to 2 hours on singly reinforced beam only, because we can say that the most important topic will be singly reinforced beam. Doesn't mean that the other topics also will not be asked. So after the singly reinforced beam, I will be taking shear design, torsion, column, and pre-stress and subsequent development length and all. We'll take that, no problem. But first of all, I wanted to focus on the portion which is asked a lot. That is what? Singly reinforced beam. Yes. So in singly reinforced beam, it is very important that first of all, we'll understand what will be given in the question, and then what will be your solution, means what will be asked. Yes. So we can say three things, right? In childhood we have studied in this manner, right? If you remember, first we'll see what things will be given. Yes. Second is what we have to find, and then we will find it, right? So these two things are important, right? So first of all, what will be given in the question? What will be given in the question? They will give a singly reinforced beam. They will give a singly reinforced beam. Okay, that means what? The design is already over. Like you see in this particular beam, what is written? A rectangular RCC beam of width 250 mm. That means what? The width is given 250. So the width will be given in the question, no worries about that. So the width is given as 250, no worries about that. Next is what? Next is written the effective depth is given, right? Okay. Okay, volume is less or I have to increase the volume. Is it fine? Is it fine? Other students can just tell. I have to increase my volume or is it fine? Is it fine or I have to increase my volume? Please mention in the comment section. As per that I will increase or decrease. Other students also please tell. Fine? Okay. Fine, okay. So if you are facing difficulty, I will request you to put headphone. Then in headphone, then it will be more clear. Yes, okay. So this is your effective depth, right? This is your effective depth. This is your effective depth. From where to where? From the top to what? Okay, top to this. Okay, okay. Very low compared to other marathon. Okay, okay, okay. I'll not answer this. Okay. Small d is your 450 mm. Okay, 450 mm. Yes, this is what? Effective depth. Then what is given? The effective cover. This is your effective cover, right? This is your effective cover, right? This is your effective cover. Yes, this is your effective cover. So this is given as 50 mm. So now from here we can find out total depth also, right? We can find out total depth. Total depth will be what? 450 plus 50, that is how much? That is equal to 500 mm. That is equal to 500 mm. Yes. First of all, I will start very slow. So those people don't have patience, they can leave the class if you want. But I will be taking it very slow because these things are most important portions. So I will be making you understand the things and the concepts little slow. Okay. So I am in no hurry. Okay. Today I am in no hurry. We'll sit nicely and cover the portion. So you also have no hurry. Be in no hurry and have patience. Okay. So this is given. Then what is given? This is 320 mm bars are given. Means what? This is the AST. This is the area of tension steel, right? Area of tension steel will be how much? 3 bars. Each bar will have area of what? It's a circular bar. So pi by 4 into 20 square. So how much you are getting AST? Tell me. Please calculate and tell me. How much AST you are getting? This is the diameter. Diameter of the bars are given. You can see that 320 mm bars are given. You see, 320 mm bars are given. Yes. So tell me, what is the area of tension steel? 320 mm bars are given. Tell me, what is the area of tension steel you are getting? Tell me. 942.42, right? If I need to be more precise, right? 942.42, right? Yes, you'll be getting 942.42. Yes, or I can take 942.5 to be on, I can round it. See, this the rounding up you can do, no problem. 942.5. 942.5 I got. Very nice. Then M25 concrete is given. That means what? Your FCK is 25 Newton per mm square. Okay. And the grade of steel is given how much? It is given Fy is equal to 415 MPa or Newton per mm square. So any question of singly reinforced beam, they will be giving you this data. So this is the given thing. This will be given to you always, don't worry. They're asking some question, they will be giving you these things. Now next thing is to find. So what things they will ask? So first of all, everybody write down these things. Yes. The first thing is what they will ask you is what? What is the first thing they will ask? The first thing they will ask is depth of neutral axis. They'll ask you what is your XU, depth of neutral axis. And how to find out? Very easy. You find out depth of neutral axis by using the equation what? C is equal to T. No need to remember the expression. Directly you can remember C expression, T expression. Now what is the compression force? That is 0.36 FCK XU into B, right? And this I will equate to what? The tension force. That is what? 0.87 Fy into AST. Now you see Fy you know, AST you know, width you know, FCK you know. You can easily find out what? XU, right? So no need to remember the expression for XU. Directly remember this equation, C is equal to T, game over. C is equal to T, game over, expression for C and expression for T. So from here I can say XU will be equal to 0.87. FY was how much? It was 415, right? And then AST, how much we got? We got 942.5, right? Very good. Divided by 0.36. FCK is how much? FCK is 25. And then width was how much? It was 250, right? So now tell me, ladies and gentlemen, what is the XU? How much XU you are getting? That will be obviously in an mm. So what is the XU you are getting? The depth of neutral axis. This is the first to find, I can say. This is the first to find. Okay, the first to find. So what is the depth of neutral axis you are getting, ladies and gentlemen? Please write in the comment section. 151.24. Others? $151.24. Okay, very good. So I'm getting 151.24 mm. This is the first thing they will ask you. Find out the depth of neutral axis. Find out the depth of neutral axis. Second thing they will ask is what? Find out the limiting depth of neutral axis. This limiting depth of neutral axis, or they can write down what? Also the maximum depth of neutral axis. Also they can ask what? The maximum depth of neutral axis. And this is what? XU limiting, right? XU limiting. This XU limiting is equal to what? It is actually equal to K into D, right? It is what? K into D. Now what is this K? This K is what? It is 0.0035 divided by what? 0.87 Fy by your modulus of elasticity of steel plus what? 0.0055. This is your K. Remember this K because they might ask this also. They might ask this also. They might ask you K also, right? Now see, this particular expression, ES is how much? ES you will take 2 into 10 to the power 5 Newton per mm square, right? Now if you multiply ES in the numerator and ES in the denominator, what will happen, you see? So this ES get cancelled and you multiply ES, that is 2 to the power 5. So what expression you are getting for K? You are getting 700, yes, divided by 700 divided by what? Divided by 0.87 divided by 0.87 Fy plus your 1100. Right? You might be knowing these things, this revision happening, right? If you don't know, then very good. Now this K is depending on what? Fy only. You can see the grade of steel. So for different grade of steel, I get different K, right? And that will be how much? For grade of steel of 250, if you put, I will get a value of 0.53. You have to remember these values for faster calculation, okay? But suppose you forget, it is also, there is a chance that you might forget that. If you forget, then what you can do? You can simply use this equation of K. Yes, you can simply use this equation of K, and in this question you see your K is how much? In this question, you can say in this question, this was general expression. In this question, what was K? Because it is Fe415, right? So K will be how much? K will be equal to your 0.48, right? 0.48. So I can easily find out XU limiting. Yes. Is PDF available? Oh my God. Oh my God. What a wonderful query. XU limiting is equal to K into D. So this is how much? 0.48 into D is how much? It is 450. So how much you are getting this? Tell me. XU limiting. XU limiting, how much you are getting? 216. Okay, 216 you will be getting. So you have to take small d. Small d is how much? It is 450 given in the question. Okay, it is given 450 mm in the question. So how much you are getting this value? 216? Yes. You will be getting 216 mm. So first of all, in the examination they might ask you the depth of neutral axis, that you can easily find out in this way. If they ask you the depth of neutral axis, you can easily find out, no problem. Yes. If they ask you the limiting depth of neutral axis, then also you can easily find out, no problem. Right. Now, if they ask a question that this is which kind of beam, this is under reinforced, this is over reinforced, or this is your balanced section. So what will be your answer? Yes, this is under reinforced or over reinforced or balanced section. Then what will be your answer? Tell me. Write in the comment section. If they ask yourself, okay, tell me what is the answer. I will draw a line. Tell, ladies and gentlemen. Under reinforced, very good. So if they ask you to check, you have to find out XU. You have to find out XU limiting. Now XU is less than XU limiting. Obviously from the question it is evident. It is 151.24 and it is 216. Right? That means what? It is, ladies and gentlemen, under reinforced beam. It is what? Under reinforced beam. That means if they ask you to check, they might ask a question, yeah, that it is under reinforced or over reinforced, balance, I don't know, you don't know. Yes. What you will do? You will find out XU. In this manner you will find out XU, and find out XU limiting and just check that which is more. Easy. If XU limiting is less, then what? It will be over reinforced. Yes. And there is very less chance that it will be equal. Less chance it will be equal. But theoretical they can ask. Yes. So the first two things they can ask in the examination. The first two things they will ask in the examination. Let us go to the next thing. The next thing is what? The next thing is your moment of resistance, or I can say the moment carrying capacity. You can say what? The moment carrying capacity, MOR, or I call it in short MOR. How to find out its MOR? Very easy. That is either C into Z or T into Z. No need to remember the big equation. Just remember C into Z or T into Z. What is C, by the way? 0.36 FCK XU into B. And what is Z? That is the lever arm, D minus 0.42 XU, right? And what is T into Z? It is 0.36. No, it is 0.87. It is 0.87 Fy into AST. It's very simple. Remember, just C and then Z, then T and Z. You use any equation, you will get the same answer. Use any equation, you will get the same answer, right? That means, ladies and gentlemen, you see, if I want to find out MOR, I have to find out this XU now. If I don't find XU, then I can't find MOR, right? So first, if I ask you MOR, you have to find out XU. Yes, very nice. I got the XU. I got the XU. So I'll rightly use. I'll use suppose this equation. So what I will write down? 0.87 Fy. AST is how much? AST is your 942.5. D was your 450 minus 0.42, and XU I think you got 151.24, right? 151.24. Very good. Very good. Now see, this you will get in Newton mm. So I'll divide by 10 to the power 6 to convert into what? Kilonewton meters. Very straightforward. Answer this. So you can go from compression side also, you'll get the same answer. Okay. I go by tension side. It is little easier. If you want to go from compression side, also no problem. You'll get the same answer. So getting 100. Getting how much? 131.51 kilonewton meter. Easy. Easy. Nice. This will be a 2-mark question. If they ask in examination, let us switch on the helicopter AC. Arey, why it is not getting? Arey. 1 second. Arey. It's not obeying me. Gaya, chodo. No problem. Anyhow, winter is going on. Okay. So this is your MOR. Next thing is what? Your MOR limiting. Next thing is what? Your MOR limiting. The limiting moment of resistance. This is written as MOR limiting, or in code also they write MU limiting. Code also write what? MU limiting. Yes. Now this is what? This is the MOR. Yes. This is what? This is the MOR. This is the MOR when the section is balanced. That means what? When your XU is actually equal to XU limiting. Yes. Yes. So what you will do? In the expression of MOR, okay, you will put in place of XU, XU limiting. Game over. That is what? 0.36 FCK, XU limiting, then what? B, then D minus 0.42 XU. Yes. Just in place of XU, you put what? XU limiting. That means if you want to find out MOR limiting, you have to find out XU limiting. Yes, but not always. I will give you another method, but for time being, this is the thing. So now put this, that is 0.36 FCK is how much? 25. XU limiting how much we got? 216. Yes. B was 250, right? D was 450, right? Then 0.42 actual limiting was how much? 216, yes. So we got all the values. Just divide it by 10 to the power 6 to convert into Newton mm. Convert to kilometer meter. So how much you're getting this M1 limiting, tell me. Put the values very straightforward and tell me what answer you're getting. 174.61. Others also please contribute. Others also please contribute. 154.65. Okay, let us take 154.65. Okay. And you can see that it was under reinforced, na? It was under reinforced. So you see XU was coming less than XU limiting. Yes, under reinforced. And therefore you see MOR, which was 100 something, 30 something, no? 130, or how much it was? MOR was how much? MOR was 131.51 is less than what? Your MOR limiting. Yes, that will happen because it's an under reinforced beam. Yes, so both will satisfy. Very nice. Now, this calculation takes little time. If you want faster calculation, this other method also. How? You see this equation, you see. I can change this equation in a way, you see. It is 0.36, okay, FCK. I'll divide this XU limiting by what? By D. And multiply D here. Yes. Then I will take this D outside the bracket. So becomes D square. Then 1 minus 0.42 XU limiting by D. Right. Now if you see carefully, this is what? This is K, na? XU limiting by D, but limiting is K into D. So this is also K. Yes. So now you see this equation. It depending on K, FCK, and then BD square. K and FCK, K depends on what? Fy. So for different Fy, we get different expression in terms of FCK BD square. Yes, and that table you have to remember. That table you have to remember. So I will say that for Fy is equal to 250, yes, this MOR limiting or MU limiting becomes how much? It becomes very simple. Remember this value, 0.148 FCK into BD square. Okay. Please put headphone. You might have headphone which you use for listening some disturbing music. So please put your headphone. 415, it is 0.138 FCK BD square. Okay. And then 500, it is what? For Fe 500, this is 0.133 FCK BD square. So I can say, you see, this is FCK BD square is common, na? FCK BD square is common. You have to remember what? You have to remember these three values, 0.148, yes, 0.138, and then 0.133, yes. And if you forget these equations, then you can use this original equation also, yes or no? If you forget these equations, then you can use original equation also. There's two methods, whichever is convenient for you, you can use. I remember these values, so it becomes easy for me to solve. If it is Fe415 in this case, the answer would be how much? Simply you see 0.138, FCK is 25, and B is 250, and D is 450. So the calculations become little easier, right? Yes, the calculation becomes little easier. Yes, the calculation becomes little easier. Yes, so tell me the answer now. With headphone, is it fine, other students? With headphone, is it fine? If with headphone, is it fine? I'm not going to increase it. All of you have headphones. Yes. So how much are you getting? Tell me this answer. 174.65. Yes, it is what? 174.65. Done? Kilonewton. So you use either this original equation or you use this equation. Both are giving you same values. Nice. Understood? Okay. Now let us understand this from code perspective. Okay. So these things obviously is coming from which code? These things are coming from which code? Obviously you know that code name. Please tell me which code this is. All these things are coming from which code? All these things are coming from which code? Which code? From which code it is coming, all these things? IS 456. Yes. All these things are coming from IS 456. Very good. Yes, all this coming from IS 456. Now, IS 456 gives the guidelines. Okay. IS 456 has a design aid. Design aid. Design aid means what? Which helps in the design. That is what? SP16. That is what? SP16. The handbook for RCC. SP16. So we'll see that from SP16 that how whatever I have taught is given in SP16 or not. So we will just close it, escape, and keep it. Okay. And we'll go to straightforward to SP16. Okay, we'll go to what? SP16. So it is visible, right? Yes. So we'll increase the size. This is our SP16. Okay. You can see SP16. Design aid for reinforced concrete. Okay. Design aid for reinforced concrete. So let us see that from this particular code, what the code is telling about this thing. Okay. So we will see the code so that we feel little confident that we have understood. Okay, this. Okay. Who is this Mr. Pavitra? Anybody please sing, please block him. Yeah, please block him. Instead of studying, he is telling hello and hi. Your whole life has gone in hello and hi. So if anybody is watching this, please block this person. Mr. Pavitra Remix DJ. Some waste of time. Okay, so here comes the code. Okay. Yeah. So we'll understand from the code. This is SP16 by the way. This is SP16 by the way. We'll understand from this code that how the equations which are given is there. You see, this you can see. You see here. You see it is given what? The maximum depth of neutral axis. You see it is visible, right? Here you see the maximum depth of neutral axis. XU max, or I can say XU limiting. It is given how much? You see 0.0035 by 0.0055 plus 0.87 Fy by ES. I just made it little. I can say I just made it little convenient for you by changing the form of the equation, right? I made it little convenient for you by changing the form of the equation to what? 700 by 0.87 Fy plus 1100. It becomes little easier, right, to remember, right? It becomes little easier to remember. Therefore, I changed the form. Yes. Now go back to the code. Yes. So this thing is what? Maximum depth of neutral axis, or I can say the limiting depth of neutral axis, which they can ask from 1 mark, right? Then you see that for different grades of steel, the code is giving what? The value of K. XU max or XU limiting by D is what? K, na? I told K. Yes. See, code doesn't write K. I have given the name K, and many people also use the name K, so that is okay. So you see this XU limiting by D, that is K, it is given how much? 0.53. Yes. For Fe4, Fe250, 0.531, you can take 0.53, right? For 415, it is 0.479, we can take 0.48. And for 500, it is 0.456, we can take 0.46 approximately, right? Yes. So you see how to find out XU limiting is given in the code. Very nice, right? Then you see that what else is given in the code. You see the MU limiting. You can see MU limiting, or I can say MOR limiting. That is also given in the code. What they have done, see 0.36 FCK B into XU max or XU limiting into D minus 0.42 XU max. You see this is given in the code. Yes. You see this equation. Yes. Now you see this equation we can use to find out MU limiting or MR limiting directly. Okay, just in the MR equation replace your XU with XU limiting, no problem. Or else the code gives this one also. You see, code gives this one also. What code has written? You see here, what code has written? MU limiting by FCK BD square. MU limiting by FCK BD square, right? You see here, this one. This I was mentioning, right? You see here, if I take, in this equation, if I take MOR limiting or MU limiting, okay, same thing. So MU limiting by FCK BD square, yes, it will give me this one, na? You see this thing, these values, na? You see, it will give me these values, na? 0.148 or 0.139, it is 0.148 something. So some books write and code even writes 0.149 actually, that is fine, minor variation. then 0.138 and 0.133. It's easier to remember, right? Let us go back to the code. Let's go back to the code. You see, 0.149, yes, 0.138 and then 0.133. So there are two methods to find out what? MOR limiting or MU limiting. Very easy. Directly you can use the equation what? C limiting into T limiting. Means what? In the equation of MOR, replace XU with XU limiting. XU limiting, XU max is same thing. Okay? Or what you do? You use directly what? These values 0.149 or 0.138 or 0.133 into FCK BD square. So both methods is there. I feel the second one is easy, right? The calculation will be easier in the examination, right? The calculation will be easier in the examination, right? The second one. If you remember only these three values, 0.149, 0.138 and 0.133, very easy. Just multiply what? FCK BD square. Understood? That becomes little easier. Let us go ahead with our class. Okay. So you see whatever is there in the code, so that I am also explaining parallel. Next, let us go to what? The next thing, that is what? The next thing is your limiting area of tensile steel. That is what? Your AST limiting. How to find out AST limiting? See, AST limiting is the AST when what? What is the condition? When XU is equal to XU limiting. So how to find out? This is very, very easy actually. See, just remember this equation. C limiting is equal to T limiting. At limiting condition, everything is limiting, right? So C limiting to T limiting. What is C limiting? In the expression of C, express what? Replace what? XU with XU limiting, right? And then T limiting, it is what? 0.87 Fy AST limiting. So don't remember separate equations. Don't remember separate equations. Just remember that you will find out AST limiting using this equation. What? C limiting is equal to T limiting. And you know the expression for C, know the expression for T. In that replace what? XU with XU limiting and AST with AST limiting. Now you can easily find out AST limiting, right? You have already got your XU limiting, right? You can easily find out what? AST limiting. Very easy. Find out. 0.36, FCK is 25. XU limiting, how much we got? 216, right? And then width is given 250. And then divide by 0.87, Fy is given 415. Tell you how much you are getting? AST limiting. Very straightforward question. Even they can ask you 2 more questions on this. Now feel that very difficult, but not difficult. Just remember C limiting is equal to T limiting, right? Just remember what? C limiting is equal to T limiting. One three four six. 1346. Very good. 1346. It is 1346 mm square. 1346 mm square. Nice. Okay. Now you see that AST is coming what? Less than AST limiting, na? What was AST by the way? The AST was 942.5 and AST limiting is 1346. So you can clearly see it is under reinforced beam, right? So under reinforced means all the three will come less. XU less than XU limiting, MOR less than MOR limiting, and AST less than AST limiting. Easy. Very easy. Now how to remember? Very easy. C limiting is equal to T limiting. Remember, simple. C limiting is equal to T limiting. That's it. C limiting is equal to T limiting. That's it. No need to remember any separate equations. Now the next thing. The next thing is your percentage tensile steel. What is this percentage tensile steel? Very easy. It is PT, that is what? Simply AST by BD into 100. And remember, this is not the total depth, this is what? Effective depth. Very easy. AST how much you got? 942.5. BU got 250 and DU got 450, right? Percentage tensile steel. Very easy. So how much you are getting this value? PT. How much you are getting PT? PT how much you are getting? Very easy. See, one question I have solved, I will solving 10-20 questions from one question only. One question will continue for 2 hours. And then many questions can be asked from that. So how much you are getting? How much you getting? Value? PT. 0.83? Yes. Getting 0.83 percentage. Getting how much? 0.83 percentage. Is the others are also getting? Please be little active in the class. Please be little active in the class. I expect students to answer little fast. Okay, I will be teaching slow, but you should be solving fast. 0.837, very good. 0.837. Very easy. This is what? PT, percentage tensile steel. The next is important, that is what? Your limiting percentage tensile steel. So that will be what? PT limiting. Yes. That is what? PT limiting. Now see, your PT was AST by BD into 100. So what will be PT limiting? It will be equal to AST limiting divided by what? Divided by BD into 100. That means if you want to find out PT limiting, you have to get what first? Your AST limiting. And AST limiting already we have got. AST limiting already we have got, right? AST limiting already we have got. So AST limiting is how much? Your AST limiting is we got 1346.1, I can say, or 0.07 we got, right? Divided by 250, and then D is what? 450 into 100. So how much are getting this limiting percentage tensile steel? How much are getting this value? Tell me. RCC is telling 1.196. That is correct, I think. I'm getting 1.196 percentage. Now you see the series, you see. See, from starting you see it was under reinforced beam. Therefore we got XU less than XU limiting. Yes. We got XU less than XU limiting. We got your MOR less than MOR limiting. Yes, or MU limiting. Yes. We got your AST less than what? AST limiting. And we even got what? Your PT less than what? PT limiting. So many things we have got, and you know it is constantly, we can say, the following the trend of under reinforced beam. Now, to find out PT limiting, we have to find out AST limiting. We can skip that step also. We can skip that step. How? You see the put expression for AST limiting. What was AST limiting? I can use the expression of AST limiting from C limiting to T limiting. I can use this as 0.36 FCK XU limiting B. This is C. From this expression you see. You see this. From here what I can say? Your AST limiting will be what? This divided by 0.87 Fy. Na? Yes. So I'll take this expression of AST limiting, right? I'll take this expression of AST limiting, right? And then use here. If I use here, what I get, see. I get is 0.87 Fy, yes, okay. And then this is for AST limiting. I'll then divide by BD, right? Because in below there is BD also. And then 100. Now see very carefully. BB gets cancelled, right? And XU limiting by D is what? It is K, na? It is K. And this 0.36 into 100 by 0.87 gives me what? It gives me 41.37. If you find out, let us find out. 0.36 into 100. 0.36 into 100 divided by 0.87. I'm getting a value of how much? 41.379. Okay, 38. 41.38 FCK by Fy into what? Into K. You see, this equation becomes easier to remember, right? And you can solve the question faster. So if they ask you PT limiting, either you can find out AST limiting using what? C limiting is equal to T limiting. Yes. And you get the answer. Or what you can do? You can directly use this expression. It becomes easier, right? So this will be how much? This will be 41.38. FCK is what? FCK is your 25. Fy is your 415. And K is how much? K is your 0.5. No, 0.48 because it is Fe 415. So how much you are getting? Tell me. How much you are getting from this? Are you getting the same value? Check it. Please check, are you getting the same value or not? $1.196. Yes, same value. Yes. So now I'm giving you two options, right? I'm giving you two options. Either you can find out AST limiting and then solve and find out PT limiting, or you can find out directly from this expression. Or directly you can find out from this expression. I have remembered this expression, this becomes easier for me. This becomes easier for me. Now you see code gives also the explanation to this. Let us see what code tells about this. The code tells, if you go to the code, you see what code is telling. Code is writing PT limiting Fy by FCK. Writing what? PT limiting Fy by FCK. You see, let us go back to the question. You see here, if I do PT limiting, this is the expression for PT limiting. This is the expression for PT limiting. Very good. This is PT limiting. Now if I do this, okay, it's not getting erased. Here I can do. So PT limiting, yes, then Fy by FCK. I'll be left with what? I'll be left with 41.38 into K only, na? You see? PT limiting Fy by FCK. I'll be left with what? 41.38 into K. Yes? Yes. So now you see what happens. This K depends on what? Only grade of steel. K depends on grade of steel, na? So for Fy I can say 250. For Fy 250, how much I will get this expression? 41.38 into 0.53, na? So 41.38 into 0.53. How much I'm getting? I'm getting 21.93. Yes. And then for 415, how much I will get into 0.48, right? So I can say 41.38 into 0.48. How much I will get? I will get a value of 19.86. Yes. Okay. And then for 500, it will be 41.38 into 0.46. So how much I'm getting? I'm getting your 19.03. Let us go back to code and what code speaks about it. Let us go back to code. So if you go back to code, 21.97, some rounding here and there, then 19.82 and then 18.87. It is almost same, right? It is almost same, right? It is almost same. Because the code is taking, why the code is getting this 18.82? Because code is taking here how much? You see, code is actually taking 0.456. We took how much? Okay, we took how much? This. Okay. Knowledge adda to all. I am not answering that question. I am not interested in answering that question. Gurudev, kitne hours ka session hai? I am not interested in answering that question. First of all, you came late. Great. Congratulations. Then you are not listening what I am teaching, and you are only interested in kitne hours ka session hai. Now, kitne hours ka session hai? How it will affect you? You please write down in the comment. I want to know that kitne hours ka session, how it affects. Instead of studying what is going on currently, kitne hours ka session hai? If you get kitne hours ka session hai, you will get the what enlightenment you will get. Please write in the comment section. I also want to know. So you see, it is 0.456 into 21.38. Sorry, 41.38. Then you are getting 18.87, right? If you multiply 0.456, right? So that, you know, minor variation happens because of what? Because of the approximation. Okay. Column design is important for RCC. Yes, column design. I will cover that also. I'll cover that in the session. Don't worry. I'll cover the column design. Important. आपका बहुत ही पुराना छात्र. See, I didn't ask you who are you. First of all, I didn't ask you who are you. Okay. And if you are your purana chhatra, naya chhatra, why you are not coming with your original name? Your parents have given you a name, right? Your parents have given you a name, right? And it is in your birth certificate, it is in your matriculation certificate. So please come with your name, first of all. And I didn't ask you who are you. I asked that by knowing how many hours, what great enlightenment you will get. Like you see, Gaurav asked this question, sir, is column design important for GATE for RCC? It's a genuine question, right? It's a genuine question, right? So such kind of questions are encouraged. So as I answered Gaurav, I'll answer size also. Yes, pre-stress concrete is also important for GATE. Earthquake water tank masonry is not there in the syllabus, so that they will not ask. Okay, you have to, and uh, first of all, you should also go to the syllabus of GATE. Many students, Parvin is preparing from 1 year, I don't know, till now you have not opened the GATE syllabus also. You want the teacher to get open GATE syllabus and tell, see, spoon feeding. Okay, spoon feeding. We will cover that also, don't worry. So please see the GATE syllabus once, okay, open the GATE, okay. Open the syllabus and see. Open the syllabus and see, na Praveen. Okay, please open the syllabus and see. Please open the syllabus and see, okay. Prasant, I have taken that 100 questions now for RCC. That will be, I have already taken that session. So in between kya hota hai? And many times I have told you, I don't understand you people, yaar. I really don't understand. I will again repeat. I have told many a times, ladies and gentlemen, the code will not change for TSPSC or GATE or ESC. I have told, many times I have told, okay, many times I have told that the syllabus remains same. They will ask you the same things. You are telling, tell us 1-2 more questions, answer in between. Same things I will be asked. After attending so many sessions where I have solved, MCQ sessions for open channel flow, RCC, where I have explained many a times. The same thing will be asked in ESC, the same thing will be asked in GATE, the same thing will be asked in Telangana, the same thing will be asked in Andhra Pradesh, the same thing will be asked in Tamil Nadu, the same thing will be asked in Maharashtra. The code doesn't change, right? It is an Indian code is applicable for all the states, right? Yes. So the code will not change. So now focus on learning. They will ask you the same things. Let that be GATE examination, let that be ESC examination. Yes, we can say that in ESC men's it will be more lengthy question. That's a different thing. Yes. But if you see the basic questions, like find out XU, find out XU limiting, find out MOR, find out MOR limiting, find out AST limiting, find out PT, find out PT limiting. Such kind of basic questions are common for GATE, ESC, Telangana. I will tell all the state names. Some students will come, sir, you didn't take my state name, so I think some different questions will come there. Different code is applicable there. No. OPSC, WPSC, WBPSC, UPPSC, MPPSC, Rajasthan PSC, Gujarat PSC, even in Goa PSC, Tamil Nadu, Andhra Pradesh, Telangana, Karnataka, Kerala, Haryana, Uttarakhand, Uttar Pradesh, okay, Punjab, Jammu and Kashmir, Delhi, yes, Madhya Pradesh, Assam, Mizoram, Manipur, Andaman Nicobar, any state, if it is a part of Indian Union, they are going to follow IS 456 and they will ask you the same question. They will ask you the same basic questions. These students, many students, I have told many a time, students don't, now again I will tell, so I will request all the students, put it in your mind, again, put it in mind. If you are preparing, the same questions will be asked in your Public Service Commission. The same things will be asked in your ESC prelims. The same thing will be asked in the GATE exam. Everywhere they are going to ask you the same question. Everybody got convinced? Okay. So whatever sessions I am taking, that will be beneficial for all the examination. Okay. Beneficial for all the exams. Yes. In ESC men's we can say that some lengthy questions will come. Or design, that's a different perspective. But if here we are discussing, simple objectives, and objective questions will be same for GATE, ESC prelims, Telangana Service Commission, any examination. So you did not worry and focus on whatever I am telling. Okay. So understood what the code is telling and how we got this different answers. Okay. How this value is coming. Yes. So very nice. Okay. Let us go ahead. Okay. At the end, I will summarize also. Whatever we have studied, don't worry. Okay. And now we are studying singly reinforced beam. Put your full focus on singly reinforced beam. Don't start thinking about this, that. That we'll see later. Now the minimum area of tensile steel. How to find out this minimum area of tensile? That is very easy. You remember the minimum percentage tensile steel is 85 by Fy. Remember this much. It is what? 85 by Fy. Very simple. So this is the minimum percentage. This will be what? AST minimum divided by BD into 100. Now remember there are 3 ASTs and there are 3 ASTs, 4 ASTs actually. Let us first discuss 3 AST and then 3 percentage. Don't confuse between them. The first one is AST, means how much is provided, right? Second one is AST limiting. This is the AST when the section is at limiting condition, means X is equal to X limiting. And this is the minimum area of steel. Yes. Now if you divide by BD, divide by BD and divided by BD and multiply what? 100, 100 and 100, you will get what? You are going to get here, this is PT, this is PT limiting, and this is what? This is your PT minimum. See, PT you will get directly from this, no other expression. PT limiting you will get from this equation also, which I derived, 41.38, then FCK by Fy into what? K. And PT minimum you will get from the which equation? 85 by Fy. Beautiful. Now, if you have got this one, then I can easily find out AST minimum, right? AST minimum will be how much? It will be used to divide this by 100, it becomes what? 0.85 Fy into BD, right? Easy, easy, right? Yes. So 0.85 Fy by BD. Okay. And this is how much? This is actually equal to how much you are getting? Answer, tell me. How much answer are you getting? To 30.42 to 30.42. And if I ask you PT minimum, what is the percentage you are getting here? It will be 0.204, right? You are getting 0.204 percentage, right? Getting 0.204 percentage. Yes or no? 0.204, na? Because Fy is 415. Just put it. So 0.204 percentage. Yes? Yes. Very good. Let us go to the last thing, that is what? Your maximum area of tensile steel. The maximum area of tensile steel. That is also very easy. The maximum area of tensile steel, AST max, is what? It is your 4%. That is your 4% of your gross area. Gross area. Gross area means total depth you have to consider. That is equal to 4 by 100. If you remember, the width is 250. The total depth is how much? The total depth was 500, na? The total depth was how much? It was 500, na? So it is 500, right? So how much you are getting this? You will be getting a value of, I think, how much you are getting this value? 5,000, right? You are getting how much? 5,000 mm square. Getting how much? 5,000 mm square. Understood everyone? 5,000. Yes. So you see here, if you see AST, there are 4 AST. One AST which is provided in the beam, that is AST. That how much I got? 942.5. That is how much is provided in the beam. That we will see from the diagram, right? PDF कहाँ से मिलेगा? अरे पढ़ लो ना भाई, पढ़ ले भाई, तू पढ़ ले, तेज प्रकाश भाई पढ़ ले, PDF लेके क्या करेगा? पढ़ ले ना भाई, पढ़ा रहा हूँ मैं, पढ़ा रहा हूँ, शांति से बैठ के पढ़ा रहा हूँ, कोड खोल के समझा रहा हूँ, 1 घंटा 2 घंटा बैठ ले, समझ में आ जाएगा, खुद थोड़ा नोट्स बना ले भाई, आलस छोड़, ओके, जाग मुसाफिर, बोल यारे, अब रहन का है जो सोवत है, उठ जाओ, थोड़ा आलस छोड़ो, लीव योर लेजीनेस, सर इज टीचिंग, टेक योर नोटबुक, स्टार्ट राइटिंग, कम ऑन, यू आर सिविल इंजीनियर्स, व्हाई दिस ऑलवेज पीडीएफ डाउनलोड कर लूंगा, रख लूंगा, क्या करोगे पीडीएफ का, 4 डालोगे, वो लास्ट में मिल जाएगा, लास्ट में यू विल गेट द पीडीएफ, नो प्रॉब्लम, बट क्लास इज गोइंग ऑन, इन क्लास यू वांट पीडीएफ, ठीक है ना, एट द एंड यू विल गेट द पीडीएफ इन द डिस्क्रिप्शन, व्हेन द क्लास इज ओवर ना, यू विल गेट द पीडीएफ, बट नाउ डोंट वरी अबाउट द पीडीएफ ना, नाउ worry about what sir is teaching. Let us understand that. Okay, now focus on the learning. So AST, then what? AST limiting, how much you got? 13, 40, how much? 46.1, right? Yes. Then you see AST minimum, that is the minimum area of steel. That how much you got? 230 point something, 42, right? See, all this one thing can be asked as objective. And therefore, I have compiled everything in one question. One thing I picked up, I am teaching everything there. It is how much? 5,000. Beautiful. Everything we got, how to find out. Let us summarize. Let us summarize everything. Okay? Let us summarize everything. And this is your homework. Okay? No, this will solve after the break. This question I will solve after the break. Okay? Okay, this question I will solve after the break. After the break. I'll take a break now, but before that, let us summarize. Let us summarize. So, in summarization of singly reinforced beam, in the objectives, and the summarization, ladies and gentlemen, is valid for you are getting so much of it just because of this PDF. Whom you are asking? You are telling me, Praveen, you are telling me that why you are getting irritated. First of all, who are you to tell me I should get irritated or not? And why I should not get irritated? Tell me why a teacher cannot get irritated. Teacher job is you come, give your orders to the teacher. Teacher is writing bada, masala bada, idli, dosa. Okay, he will take your orders and then you will not listen to him. You give pass orders and what teacher is telling, you will not listen to suggestion. So you have become very great then, great personalities. So teacher can't tell his irritation also. Why the teacher can't get irritated? Okay. No, I am not irritated. I am not irritated. I am scolding. I am not irritated. I am scolding. I don't get irritated. I scold. When I feel that the student needs some medicine, then I give some medicine. Okay. Now coming back to summarization. Okay, now focus on summarization. Enough of all these things. Let's come back to summarization. So in the examination, what will be given to you? You tell me what will be given to you. Tell me. In the examination, given will be what? You tell me. Come on, start. What will be given to you in the question? Data given in question. Tell me. Tell me what will be given in the question. Tell me. What parameters they will be giving in the question. Tell me. Come on, start. What parameters they will be giving in the question. Come on, tell me. Width, yes. Either they will give you effective depth, they might give you cover also, and from cover you can find out what? The total depth also. Yes. Cross section material. Tell me, be specific. BD, FY, FCK, very good. And last thing. Anything? AST, yes, AST. If they don't give the AST, they might give the number of bars, right? So from the number of bars and diameter of the bar also can find out the AST, right? My health is perfectly fine. It is the number of bars. And is the number of bars, and phi is what? Phi is the diameter of bar. Diameter of bar. So from diameter of bar and number of bars, you can find out AST. Yes. So all these things will be given to you. Okay. Now coming to what things they will ask. The first thing they will ask is XU limiting. XU limiting is simply what? It is simply K into D. And I told there are three values of K, 0.53, 0.48 and 0.46. That depends on what? That depends on the grade of steel only. And if they ask you XU, what you will do? From where you will get the expression? Simply C is equal to T. Simply C into T. Game over. Simply C into T. Game over, right? Then third is MOR. How will you find out MOR? You have got your XU, you have got your C and T, directly CZ or TZ means equal to, both will be the same value, but you have to get what? You have to get your XU. Yes. Next is MOR limiting. MOR limiting or MU limiting, I told two methods, right? This is XU max also. By the way, this is XU max also. So MOR limiting and MU limiting, there are two methods. Either directly you can use what? C limiting into Z limiting. Yes, C limiting, Z limiting. In place of XU, put what? XU limiting. That's it. Or I told, you have to remember this table, right? Dash into what? FCK BD square, right? Dash into FCK BD square. Actually, yes. So this is what? 0.48, 148, 0.138 and 0.133. Okay, very easy. Two methods I told. Then we went into what? Your AST limiting. AST limiting, how you will get from which expression? C limiting is equal to T limiting. Very straightforward. C limiting equal to T limiting. Very easy. Yes. Then if they ask you PT limiting, that are two methods. Either you use what? AST limiting. You find out AST limiting by BD into 100. Or I told what? Use this. 41.38 FCK by FY into what? Into K. Into K. Yes. Easy. Yes. So two methods are there. And then next thing, the next thing is, this was seventh thing, na? Sixth, na? Seventh. Sorry. Seventh. Seventh thing they can ask is what? Your PT minimum. PT minimum is very simple. It is what? 85 by FY. And then if they ask you what? AST minimum, that is also very easy. From PT minimum you can find out what? 0.85 by FY into BD. Yes or no? And last, if they ask you what? AST max. And ladies and gentlemen, it is applicable for all the examinations. Again, I will tell. Simply 0.04 B into capital T. Nice. Everything in one go, right? Everything we have summarized in one go. Okay, anything they ask you now from single reinforced beam, we are ready. Some more things are there, we'll see after the break. But anything is asked, you can easily answer now. Yes. T-beam is, they can ask a question. No doubt they can ask a question. I will not say they will not ask a question. There is chance that they will ask a question from T-beam. Okay. Chances are less, but not zero. Okay. I have covered the T-beam, the flanged beam in the app. Okay. In the app, in the Learn with Modulations. Okay. That is available. If you want to study, you can study from there. But chances are less, but doesn't mean that zero. They can ask in the gate. It's not lengthy. It's very easy actually. It's not lengthy actually. It is just that people don't teach it in a very efficient manner. Even they make single reinforced beam look like, see, in 1 hour single reinforced beam I have, done. Yes. People don't teach it in a nice way. That's a different thing. Okay. Now coming back, some theoretical questions also they can ask. WSM is not important. If Praveen, have you studied from some place, or you don't know the WSM where they ask and all what you are telling? I don't know what you are telling. 1 year you are telling you studied 1 year and you do not know WSM, they will ask or not. They will not ask. They will ask some basic questions of WSM that is covered in the app. Now they will ask you these things. Okay. Now suppose A is your FCK, okay, B is your FY, okay. Now tell me one thing, this first XU limiting, it depends on what? Tell me. It depends on A, B, okay, A, B, or now Praveen, I will not be answering your question till the end of session. First of all, it is GATE marathon. Okay. First of all, it is GATE marathon. If you want to you are preparing for EAC, you are a very enlightened soul. You are we don't have the level of your okay. And I don't know that in EAC last time which question they asked. I am a fool, na? I exactly know what question they asked. Yes. So if if you think that you are more intelligent, so please continue. Okay. And please somebody block him. You're disturbing the class actually. You're really disturbing. You're very disturbing element here. Very disturbing here. Something is going on nicely for the GATE examination. You are very enlightened, and anyhow, Praveen, ladies and gentlemen, has told one time that I don't want state services, I don't want GATE, I just want EAC. So you want EAC now? Then go to EAC and prepare somewhere. Don't attend GATE sessions because we are very low level people. Okay, you are very enlightened soul. Always you want to just bring EAC just to show that you know a lot of things and we don't know anything. Okay. Now One comment you do, Praveen, I am going to stop the class. One comment from Praveen, I will stop the class. I am telling you. You want to harm other students? So you can harm. One negative comment, I will stop the class. I am warning you. And I am not irritated, I am angry. So XU limiting, tell me, depends on what? It only depends on B. It only depends on B. Second, tell me XU depends on what? Tell me. XU depends on what? These theoretical questions they can ask. XU depends on what? XU depends on what? XU, tell me XU. XU obviously depends on C. XU limiting is K into D. There is no FCK, right? There is no FCK, only FY is there. Now XU depends on what? Tell me. XU depends on both. Yes, it depends on both A and B. See, such kind of theoretical questions are asked. In all examination they ask this question. In all examination they ask this question, right? Theoretical questions. Third, if I ask you, your MU limiting or MOR limiting, it depends on what? Tell me. MU limiting and MOR limiting, it depends on what? Tell me. MU limiting or MOR limiting, it depends on what? Let us see. MU limiting and MOR limiting. Depends on what? Both A and B. I will answer why. You see, MOR limiting equation was what? Something into FCK BD square, right? Something into FCK BD square. That means depending on FCK. Yes, it is depending on FCK. But this something, that is what? 148 or 138 or 0.133. This was depending on what? Tell me. This was depending on what? This was depending on Fy, na? Yes or no? This was depending on Fy. Yes. And therefore it depends both on what? FCK and Fy. Depends on both FCK and Fy. Yes. And ladies and gentlemen, such questions are asked in ESC also, GATE also, state services also. All these questions are asked in all the examination, right? So we saw the numerical things. Now I am more focusing on the theoretical aspects also. Now fourth thing, tell me. Fourth thing, tell me. PT limiting, it depends on what? That is very easy, na? PT limiting is very easy. Tell me, PT limiting is very easy, na? PT limiting is depending on what? Tell me. That is very easy. PT limiting is depending on what? PT limiting depends on what? Both. Yes, 41.38 FCK by Fy into K, right? So it depends on both A and B. Both A and B. Both A and B, na? PT limiting, not minimum. See, you get confused between this. PT limiting is limiting and this is PT minimum. These are two different things. They are not same. They are not same. They are not same. PT limiting and is not same. PT limiting is what? 41.38. You see this expression. Both. Right? Okay. Then question number 5. PT minimum depends on what? Now tell me the answer. PT minimum depends on what? Tell me. PT minimum depends on what? This is very easy. PT minimum depends on what? Fy only. Yes, it only depends on Fy. It only depends on Fy. You see, only depends on Fy. And if I ask you, AST maximum depends on what? If I ask you, AST maximum depends on what out of these two quantities? Tell me. AST maximum is important for what? Tell me. Depends on what? None. Yes, it depends on none. You see simply what it is, 4%. It is what? 4% of gross area, and it is irrespective of the grade of concrete or grade of steel. Such kind of theoretical questions will be asked in GATE also, ESE also, state exam also. Everywhere they ask you questions from singly reinforced beam limit state method is concerned. Yes. So you can clearly see that this kind of theoretical questions, this kind of numericals can be asked in any examination. Can be asked in any examination, right? Now, some more thing. I will write G for geometry. I will write what? G for geometry. Okay. G for geometry. XU limiting geometry means what? The dimensions, right? Okay, certain confusion in 4. PT limiting is this one. Na? See, PT limiting is this one. Na? See, expression you see. PT limiting expression is this. Na? So, 41.38 FCK by FY into K. So, FCK depends on FCK, depends on FY. Isn't? Now clear? Clear? Limiting is different, minimum is different. Limiting is the condition where XU is equal to XU limiting. That is limiting condition. Minimum is different. Minimum is this much minimum amount of steel we have to give. So that is a different condition. So always remember, minimum is the 3 conditions. Minimum is different, limiting is different, maximum is different. There are 3 different things. We get confused in this. Limiting is the condition when the section is balanced. Means what? XU is equal to XU limiting. That's a limiting condition. That is what? Limiting. Minimum is minimum area steel. Maximum is maximum. Understood? I might have misspelled, told minimum. Okay. Understood everyone? These 3 things are different. Never confuse between these 3. Limiting, minimum, maximum. There are 3 different, entirely different conditions. So don't get confused. Easy. Now, coming back. G for geometry. Let us see that which of the parameters depend on geometry. XU limiting depends on geometry because geometry means dimensions. Geometry means what? Dimensions means what? B and D. B, D, small d, whatever. So XU limiting depends on small d. So yes, it depends on geometry. XU depends on geometry. 0.87 FY AST. Yes. And C is what? 0.36 FCK XU into B na. So XU is what? 0.87 FY AST divided by 0.36 FCK into B. So depends on B na. So depends on geometry. MOR limiting obviously depend on geometry. Yes. Because that expression was what? 0.138 or 0.148 FCK BD square. So obviously depends on geometry. PT limiting, it doesn't depend on geometry. You see? PT limiting, is there any geometry term? You see? 41.38 FCK by Fy into K. Is there any geometry thing? There is no geometry thing here, right? There is no geometry. So it doesn't depend on geometry. It is independent geometry. Means what? Independent dimensions. Independent dimensions. PT minimum 85 by Fy. That is also independent of geometry. Yes. Not depending. AST maximum. Yes, it depends on geometry. Because that is what? 4% of gross area. So gross area changes what? This will change. Right. Now, if I ask you AST minimum, see AST minimum depends on Fy, means what? AST minimum you see. AST minimum depends on Fy. That means what? It depends on B and AST minimum depends on the geometry of the section. AST minimum depends on geometry section. Right? But the maximum, this other things like PT minimum doesn't depend. So these theoretical questions, everybody is clear or not, ladies and gentlemen? Please write in the comment section. All the possible theoretical questions like this, yes, and the numerical aspects, all the numerical, most we can say probable numericals for the singly reinforced beam, okay, that I have covered. Everybody is now convinced that they have got a good idea. Let us see from code once. I'll just visit the code once. Let us see that what the code tells about all these things. You see, I'll just decrease the size here. Yes, you see, from the code, you see, if you see from the code, can I edit this? Yes. Can this be edited? Yeah, it can be edited, right? Okay, no, but, okay. Highlight option is there. Okay, highlight can be highlighted, yeah. So from the code, if you see, from the code, if you see, this equation is very important. We covered this equation, right? XU, yes. And then you see this table we covered, right? This K values, right? This K values we covered, right? K values we covered, right? Then you see here, yes, PT limiting, you see, PT limiting for different FCK and Fy, we get different PT limiting, right? and those percentages are given but is not required. You can find out also. Okay, you can find out also. Okay, then you see mu by bd square, fc by bd square, this table and this table we covered, right? Nicely we covered, right? Nicely we covered. Yes. So all these things you can easily find out. Okay, and I explained everything from the code. Actually, if you see, I have explained more than the code. The code, just write 4-5 equation, game over. Okay, so I explained more than the code and everything is there now. Understood? Such kind of questions will be asked. Now we'll take a break. Now mind is now little tired, ladies and gentlemen, right? Mind little tired. So we'll take a break now. Okay, like a break now. 10 minutes break we will take. So 12 minutes break we'll take. So break time. Break time. We'll meet at 11:35. 11:35 a.m. class will resume. Okay, and we'll be covering more aspects of your singly reinforced beam. So please, if you're interested, please come. If you feel that you know more, okay. As Kanchan sir, no, 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 I am not so great as him. Okay, I am not so great as the name mentioned. So thank you very much. We'll meet at 11:35. Welcome back. Okay, so we are back. Okay, so it was 11:35, we went to 11:40. So nice. Okay, nice. Okay, so 11:40, 5 minutes delay, no problem. Okay, so if you are all here, please write once yes sir. So we'll start the class. By that time I will try to open this helicopter AC. Just write down yes so that we can resume. Yes, the helicopter AC is on. Okay, so let us resume the class. Okay. Now, apart from this all straightforward questions, so these questions were very straightforward, right? All these questions were very straightforward. Now, apart from the straightforward questions, they might ask you what? Some different type of questions. So, we'll see some different type of questions, okay? Some variations from the questions, some variety of questions. You see, in our beam, there were 3 20 mm bars were provided, right? 3 20 mm bars were provided. 3 20 mm bars were already provided in our beam. The question is same, I am just extending to different, we can say different other things which they can ask in the examination. Okay, so 3 20 mm bars were provided. Now what is the question? The question is additional 20 mm bar to be added, okay, to make the beam just over reinforced. Okay, so this is the interesting question. What is the interesting question? So first of all, our beam was under reinforced, right? Our beam was under reinforced. Under reinforced. Why it was under reinforced? Because the AST provided was what? Less than AST limiting, right? So when I say just over reinforced means what? The AST becomes greater than AST limiting. Now AST limiting is fixed, right? This was how much we got, that is 1346.07, right? And the AST provided was 3 mm of 3 bars of 20 mm, that was 942.5. Now when it becomes over reinforced, when the area of steel is greater than AST limiting, which still remains how much? That still remains 1346.07. So this is what? 3 bars 20 mm. Now can you tell me how many bars I will add? How many bars I will add so that it becomes over reinforced? Answer this question then. Answer this question. Let us see who answered this question. How many to be added? Additional. Already 3 are there. How many I will add to make it what? Just over reinforced. Answer this question. Two bars. Very good. 2 bars. See, just over reinforced means I can say AST is equal to, I can also say, just means what? Greater than equal to, right? Equal to. Now when AST is equal to AST limiting, suppose, that time I can say number of bars, suppose n. So what I can say, n into pi by 4 into 20 square is equal to how much? 1346.07, right? So from here, n you are getting how much? You are getting 4.28, right? You are getting 4.28 bars. Now obviously I cannot provide 4.28, okay? And 4 will not do, so I'll provide how many bars? I'll provide 5 bars. Round to the next integer, round to the next integer, next integer. So 5 bars I have to provide to make it what? Over reinforced. See, at 4.28 bars, this is equal to, at 5 bars what will happen? At 5 bars it will be how much? AST will be greater than AST limiting, right? That becomes what? It becomes over reinforced. At 4 it will be still under reinforced, right? At 4 it will be still under reinforced, right? So now it is over reinforced. So a total bar is how much? 5 bars. Already 3 bars are there. Already 3 bars are there. So how many additional bars? Additional 20 bars is how much? It is additional 20 bars is equal to 2. Everybody understood this question? Such kind of question they will ask, right? And if you want to solve this question, ladies and gentlemen, first you need to know how to find out AST limiting. Na? If you know how to find out AST limiting, then only you can do the other stuff. Everybody understood this question or not? Tell in the comment section yes or no. Such kind of questions should know how to find out AST limiting. Then only you can do the comparisons. Answer yes. Now to this I will add one thing. To this I will add one thing. Okay. What I will add? I'll add one thing. Suppose I am giving you this thing. Suppose I am giving you that additional number of, tell me, additional number of 20 bars which can be added, keeping the, I can say, maximum number of additional 20 bars, maximum number of additional 20 bars which can be added keeping the beam under reinforced. What is the answer? Tell me. Very straightforward. Answer me. Answer this question. Maximum number of additional 20 bars which can be added keeping the beam under reinforced. Answer this question. One. Yes. See, when there were 3 bars, AST was how much? It was 942.5. Yes. It was less than AST limiting. Yes. Now if I add 1 bar, so what will happen? It will become 4 bars. At 4 bars, what is the AST? The AST will get how much? Will get 1256.6 suppose, or 7 suppose. That is still less than AST limiting, right? That is still less than AST limiting, right? If you make it 5 bars, then what is happening? AST will be equal to, I can say, 314.2 into 5. 314.2 into 5, that is how much? 1571. Now it becomes greater than what? Your AST limiting. Yes. Now AST limiting, how we got? From C limiting or T limiting, that is how much? Fixed. 1346.07. So you can see that it was the initial condition. If you add 1 bar, still it remains what? Under reinforced. But if you add 2 bars, what is happening? It is becoming over reinforced. So as per the question, you see, as per the language of the question, what is written? Maximum number of additional 20 bars which can be added keeping the beam under reinforced. That is 1. Because if you add 2, what will happen? If you add 2, then it will become over reinforced. So this such kind of questions they will ask in the examination. And if you want to answer such kind of questions, you should know how to find out AST limiting. Yes, how to find out AST limiting. And how to find out AST limiting? AST limiting can be found out using what? C limiting is equal to T limiting. Very simple. And then you can compare based on what? What is the question given. So everybody understood this kind of questions? Everybody understood this kind of questions? They can easily answer, right? This kind of variety questions they can ask. Understood this kind of questions? Very good. Let us go to some more types of questions which they can ask from singly reinforced beam. That is assumption change. They will change some assumptions and they will ask you a question. For example, if they say that the maximum strain in steel, the same question I am asking you, maximum strain in steel, not steel, concrete, is how much actually? Tell me. What is the original value? Tell me. Original value is how much? Tell me, what is the maximum compressive strain? It is compressive strain. So what is the maximum compressive strain in concrete? Tell me, what is the original value? What is the maximum compressive strain in concrete? Original value, tell me. Original value is how much? 0.0035. 0.0035. If this is the original value and they are telling that the changed value, suppose they are telling the changed value is 0.003, suppose they are writing what? 0.003. 0.003. Or suppose let me change it to 0.0025, suppose. The change means what? The assumption has changed. Assumption change. So if they do this and they're asking you what? Find actual limiting, suppose. Asking you find actual limiting. The actual limiting equation will remain k into d only. And d is given how much? 450, right? D is given to us 450. But the k equation will change, right? How? If you remember, what was k? K was 0.0035, yes? Divided by what? 0.87 Fy by Es plus 0.0055. This 0.0055 was actually equal to what, you know? It was actually equal to 0.0035 plus 0.002. So now the assumption change. So what will happen? If the assumption change, what will happen? This will change to how much? This will change to 0.0025. This also change to 0.0025. So what will happen to this? This will change to 0.0045. Na? Yes. Now when you multiply ES was 2 into power 5. So this K equation changes to what? Earlier it was numerator 700, right? Now it will become 500. Na? Yes, it will become 500. Then it will still remain 0.87 Fy, no problem. But that was 1100, it will become how much? 900. So now you can see here, I cannot use 0.48D, na? I cannot use 0.48D because that 0.48D for Fe415 steel, which we saw before, that was for Fe415 steel when the assumption is 0.0035. Now it changed to 0.0025. So what happens? Things changed. So now tell me the value of K then now. Now tell me the value of K for this changed assumption. It will be how much? It will not be 0.48. It will be how much? Tell me. Put the values. Fy is 415. Tell me what is it getting from this changed equation. Now these kind of questions have less probability of asked in a state examination. So all the straightforward questions I have already solved. This is, you can say, this I can say is your little complicated 2-mark questions which they can ask in the examination. But straightforward questions are already covered. 0.3965, okay? More accurate 0.3965, right? You are getting 0.3965, right? Yes. So 0.3965 into D it will become, right? And if you put the values, 0.3965 D was how much? It was 450. So how much you are getting the value? Question is remaining same, the assumption changed. This is becoming 450, right? Yes. How much you are getting? Tell me this value. So earlier which was 216, that will change now because the assumption changed. You are getting how much? Tell me the value. 178.423, or I can say 4, suppose 4, okay, kilonewton meter. Or if you take 0.4 also, you will get approximately 180, right? Yeah, if you take 0.4 you get 180, so 178.4 I can take. Understood? mm, sorry. Understood everyone? How the actual limiting changed? Because the assumption changed. So you see, when the assumption changes, you have to do subsequent changes in the equation. How to do, I am teaching you. Okay. Next thing, the assumption changed. When the assumptions change, how we find out XU? XU we found how? XU is actually C into T. So when I use C into T, see T expression will not change. It will remain what? 0.87 Fy into AST. But the C expression will change. Okay? Sir, axial compression bending is different values. Please give space, clarify. I didn't got. It is only pure flexure. Pure flexure will take 0.0035. Pure flexure is 0.035. Okay, we are discussing only flexure. We are not discussing axial compression. Okay, it is pure flexure is only bending versus beam, na. That thing is in column. What you are telling is in column. Okay. Now see, the C expression will change. How the C expression will change? Let us understand that. Let us understand how the C expression will change. For that, I have to go to the derivation of C expression. For that, I have to go to the derivation of C expression. Okay, let us see. See, this was the stress diagram for your compression, right? Yes. This was stress diagram for compression. Yes. Now see, if you remember, what was the original strain diagram? The original diagram was like this, right? That this was 0.0035, right? And the parabolic portion, the straight portion, this straight portion, this was 0.45 FCK, right? This was 0.45 FCK. This was till strain of how much? This was till strain of 0.002, right? This is the original diagram. Yes. But now the diagram has changed. This become how much? This become 0.0025. This becomes what? 0.0025. Yes. Now, suppose this is P and this is Q. Suppose this is P and this is Q. This total is what? This total is XU. So can you find out P and Q with respect to XU? Yes. If you see the triangles, you see this triangle and the big triangle. This triangle and the big triangle. I will take similarity of triangles. Okay, I will take what? I will take similarity of triangles. If I take similarity of triangle, this small triangle, this big triangle, then what I can say? I can say that Q by XU, small triangle by big triangle. You see, small triangle is Q, big one is what? Your XU. Yes. This equal to how much? I can say it is 0.002 divided by what? 0.0025. Getting how much? This is getting 0.8. So Q is equal to 0.8 XU. So automatically what will happen to P? P will get 0.2 XU. This is 0.8, this is 0.2. Very easy. Very easy. Easy. Now once we get these two values, I can find out the expression for C. C is what? C is just the area of these diagrams. C is just the area of these diagrams. Yes. You see the rectangular part. Rectangular part is what? 0.45 FCK into P. So 0.45 FCK into P is how much? P is your 0.2 XU. 0.2 XU. Right? And ladies and gentlemen, the parabolic part area is how much? 2 by 3 base into height. Base is how much? 0.45 FCK and height is how much? Height is your 0.8 XU. Yes. Now this whole thing multiplied by B. This whole thing multiplied by what? B. Yes. So what is the expression for C you are getting now? What is the expression of C you are getting now? 0.09 and this get cancelled, 0.03, 0.24, 0.33 you will be getting. You will be getting 0.33 FCK XU into B. Why into B? Because this stress is acting over this whole width, na? And therefore this stress area into what? B I did to get what? Total compression force. Everybody understood this concept or not? Everybody understood this concept or not? Now chances is less in the GATE examination. Sometimes they have asked, but still, you know, I want to explain this. Okay. So we got, yes. Now after assumption change, what will happen? Now if you want to find out XU, so 0.33 FCK, the exchange expression, 0.33 FCK into XU into B is equal to what? 0.87 FY into ST. T expression doesn't change, because if your strain changes, then the stress diagram of compression changes. Very easy. Now you can easily find out XU. XU is how much? 0.87. Fy is 417. ST is how much? 942.5. We have already got same question. No. Telangana, no chance. I told na such kind. See, in Telangana state and the state examination, they will ask you straightforward questions. So all the straightforward questions which I discussed before the break, those questions can be asked, in your state examinations. Now these variations, they can be only asked in ESC or GATE. Okay. So 0.87 Fy into AST divided by what? 0.33. FCK is how much? FCK is 25 and Fy was 25 and B was how much? B we got is 250 na? How much? B was 250 na? Yeah. So tell me how much you're getting XU? Okay, so XU क्या getting? Tell me, what is the answer getting? XU 160. Let us take it 165 almost, right? We can take 165 mm. Getting 165? Yes. Now tell me, it is under reinforced or not? Under reinforced, still under reinforced. You see, it is still under reinforced, right? Still under reinforced, right? Yes. Yes, because this you got as 178.4. Yes, still under reinforced. Yes. Understood? Very good. So when assumption change questions are asked like this, you have to do subsequent changes. You have to do subsequent changes. Like what I told is that in assumption change, you have to see that what is changing. For example, if I give this question, okay, clear design we'll see after some time. So assumption change, which I told that chances are less, but in the examination chances are less, but still they are there for GATE examination, so therefore I am teaching. And in assumption change, one thing they will change is, first change that is strain change, this maximum strain. Maximum strain. So if they change, the maximum strain is changed. When the maximum strain is changed, so what will happen? Automatically K will change, na? Yes. Automatically. Automatically K will change. अरे बाबा गुजरात में भी नहीं पूछेगा. No state exam chances are, see, try to understand, chances are less means not zero. Chances, sir, whenever I say chances are less, it's not zero. Certainly if somebody wants to ask, they can ask. But chances are less means very less chance. So K will change. Okay? K will change. How it will change? I explained how it will change. So K will change means what? Your XU limiting will change. Your XU limiting will change. Your XU limiting will change. Yes? Okay. Best civil engineering teacher. Hey Baba, best civil engineering teacher as per me, okay, you have seen, okay, that might be possible. You know, RCC, I will tell you from where I have learned. I will tell you. RCC from where I have learned. Many students, I have learned RCC from my professor, Jain Bandyopadhyay. He was my professor in IIT Kharagpur. So JNB sir, we used to call him. Okay, very strict sir. So Jain Bandyopadhyay, he was my professor in IIT Kharagpur. Okay, so from him I have learned. So as per me, he is 500 times minimum better than me. Okay. Then I have also learned RCC from Devdas Menon. Devdas Menon is professor IIT Madras. Okay. Means our times we used to call Madras, now it is Chennai. Okay, so IIT Madras. Okay. And I have also learned RCC from Professor P.C. Varghese. Okay, he is also a very famous professor. So my knowledge is from them. So I do feel that JNV sir, I have never attended the class of P.C. Varghese sir. I have attended class of Devdas Menon sir and Jain Bandyopadhyay. So for me, they are like minimum 500, 600 times better than me. Minimum. I will not, might be more actually. Yes. So they are the best teachers for me in RCC. Okay. Next, let us go to, so when they write maximum strain is changed, XU limiting will change. Now, second thing, when maximum strain changes, what will change? The stress diagram will change, na? Yes, the stress diagram will change. Okay, the compression stress diagram will change. Compression stress diagram will change. Okay, because that maximum stress changes, then that means what? You have to find out dimensions and all, how I have explained. So which will change? C expression will change, right? C expression changes, will XU will change. How it will change and all, I have already explained to you. Okay, so this is a type of thing which you can ask. See, more complicated MOR and all, I'm not going. I have taught those things in the app. If somebody wants to see, they can go to the app, and there in the learn with relations, I have explained more complicated things. I'm not trying to make it complicated now because not required so much. Second assumption change they can ask is what, you know? Second assumption change they can ask is what? Okay. Second assumption they can ask is, they can change directly, they can change the stress diagram. They can change the stress diagram. How? The shape of the stress diagram, right? Means what? They can make it like this, you see. The strain remains same. Suppose the strain remains same. Suppose this is still 0.0035. Yes. Okay. But instead of parabolic, they make it what? They make it triangular. Or instead of like this, they might make the stress diagram like this. Yes. For them make the stress diagram like this. So what will happen? In this case, C will change, na? In this case, C will change. So XU will change, na? But XU limiting will not change, na? XU limiting will not change. Because XU limiting only depends on strain. If the strain diagram is same, na? Yes. When the strain diagram is same, then what will change? Only the C expression will change. Okay. So if you want to solve more questions, you can go to the app. Okay, so I'm not going into more details because not required that much. Some basic things which they can ask, I have already explained to you in this particular thing. Some more complicated questions I have explained in the app. You can go to the app, download the app, learn with video lessons. There you will cover. I have covered this thing details. Let us go to shear design. So we have seen sufficient of what? Sufficient of singly reinforced beam. Singly reinforced beam, I discussed what? Flexor design, means bending design, pure bending. Let us go to shear design. In shear design, the most important thing they ask is what? Spacing. They will ask you what? Spacing. Let us take the same beam. Same beam I am continuing. Same beam I am continuing. I'll now learn the points because I have brought the data and all. So we'll see from code also. That same shear design also I'll explain from code also. Don't worry. So suppose I am giving you that I have to use stirrups, and suppose the factored shear force is given as, suppose it is factored shear force is given as 150 kilonewton. Okay, 150 kilonewton, and I am telling that the stirrups are 250 grade. See, stirrup can be different. Stirrup can be different from what? From the longitudinal steel. See, longitudinal steel, how much we got side? So do you have to design for side and first? We have to design. Okay. But I am discussing only here shear design, so let us focus on that. Okay, so two-legged, okay, your 8 mm stirrup is given. Okay, and we are not designing here, ladies and gentlemen. I am solving questions for GATE examination. That what things they can ask. Okay, let us focus on that. So two-legged 8 mm stirrup is given. Okay, we have to find out the spacing. Find out spacing. Okay, find out spacing. So this is given to you. Obviously, these things will be given to you. Okay, given to you, and they will be given you what? The PT versus tau C data, right? PT versus tau C data they will be given to you. Don't worry, they will give you a table. Okay, and this is for which grade of concrete? This is for M25 because this question was having M25. So PT and then tau C. Tau C is what? Shear strength of concrete. So suppose they are giving you for 0.49, suppose not 0.49, for 0.5, tau C is 0.49. I have taken from code, okay? And this will be given in the question. First I am writing what is given in the question, right? 0.57, and then for 1 it is 0.64. For 1.25 it is 0.7. Very good. This is your design, very nice. Now here you see this much is given. Okay. Now what is asked? Spacing of stirrups. To find is what? Spacing of stirrups. Spacing of stirrups. Now when you want to find out spacing of stirrups, the first thing you should do is what? You find out first stepwise. First you will find out the nominal shear stress. What is the nominal shear stress? It is the VU by BD. BU is given 150, right? As Crocodile has found out. Okay. 150 into power 3 divided by B into D. B was how much? Same beam, same beam. So 240, 250 into 450. So how much you are getting this tau V? Tell me. How much you are getting tau V? How much you are getting tau V? How much you are giving finding tau V? As Crocodile has found, others also find out. Please tell. Don't just write down. Also understand. How much you are getting? Sorry. How much you got? 1.33. 1.33 Newton per mm square. Okay. 1.33 Newton per mm square. Very good. The second thing is to find out what? Tau C. Tau C you will get from this table, right? From this table. For this you have to find out what? The PT percentage. This is in MPA. You have to find out the PT percentage. PT percentage we have got, na, remember? PT percentage was how much? ST by BD, right? ST by BD into 100. We have got already, right? So how much you are getting this PT percentage? Tell me. How much you are getting this PT percentage? How much are getting PT percentage? Are we got already na 0.837 na? Remember? 0.837 we got already. Forgot? Huh? 0.837 we got na initially PT percentage, right? Now 0.837 means it is lying somewhere here na, you see, between 0.75 and 1. So I'll interpolate, right? I will interpolate. And I'll get the value of tau C as how much? You see it is 0.57 plus 0.64 minus 0.57, right? I'm interpolating, linear interpolation. Then 1 minus 0.75 into what? What is my PT? My PT is 0.837. So 0.837 minus 0.75. So how much are getting tau C? Tell me, interpolating, tell me how much are getting? Interpolating, how much are getting? Linear interpolation, linear interpolation. So first you get the PT, yes, PT is very easy, AST we already know, PT is what? AST by BD into 100, and then from the table you will get the, by interpolation between two values. So how much tau C you are getting? You will be getting 0.59 something. It should be between what? Between 0.57 and 0.64, na? We are getting some 0.59, 592, 59 something like that. How much are you getting? Tell me. Uh-huh. 0.594. Getting how much? 0.594 Newton per mm square. Linear interpolation between what? Your these two values. Linear interpolation 0.594. Very easy, very easy. Once you go tau V and tau C na, game over. Once you get tau V and tau C na, game over. The spacing is what? The spacing is this. SB less than equal to 0.87. Fy, then what? ASB divided by what? Tau V minus tau C into B only. Straight formula. Straight formula. Less than equal to 0.87. Fy is how much? Fyu is how much? 250. Here you see. The stirrups are provided like this. Suppose the cross section I am drawing again. Okay. The stirrups are of different grade and the main reinforcement of different grade. Yeah, this is the main reinforcement. Yes, the main reinforcement is Fe415, right? But the stirrups are of which grade? That is of Fe250. It is given in the question. They can be different, they can be same. Okay. So how much are you getting? 250. Then area, it is two-legged, so I'll use 2 into pi by 4, 8 mm dia, so 8 square, right? Two-legged means what? One leg, two-legged, right? So two-legged like this, divided by tau v minus tau c. Tau v is 1.33, tau c is 0.594, yes, and b is how much? B is your 250. So how much spacing you are getting? Less than equal to how much? Less than equal to how much? Less than equal to how much? $118 point something you will get. 118.77. I think 196 you will get if you are using this 415. Okay. 118.77. 296 how you got? You will get 118 point something. Get 118 point something. I am also getting 118 point something actually spacing. 118 point something I got. 118.8 I got actually. Okay. So it will be less than this. Okay. So suppose for see value. Suppose it is data entry. You will enter this one. And suppose it is option 1. Suppose option 1 is given. Options are 120, 115, 130, 150. What is the right answer? If options are there like this, if options are like this, then which is the right answer? Options are like this, which is the right answer? $115, very good. Less than equal to, always remember, spacing has to be provided less than equal to 115. Less than equal to, okay? Don't think that 120 is near to 118.77. No. Less than equal to. Yes. So now, in shear design, if they ask you, most things I'll discuss. In shear design, if they ask you to find out the spacing, which is very common question in shear design. If they ask you to find out spacing, first of all, you get what? You get the tau v. Tau v is what? The factor shear force divided by BD. Very easy. Then you get the tau c. Sometimes now they give the tau c. Tau c is what? It's the shear strength of concrete, or I can say allowable shear stress in concrete. So it's given, very good. If it's not given, you can find out what? From the which table? PT versus tau c table. In the table will be given. You have to find out the PT. PT how we'll get? PT is AST. The provided one, we know it will be given in the question, into BD, divided by BD into 100. So from you can find out tau c. And once you get the tau c, the spacing has to be less than equal to what? 0.87. Okay. Fy, yes, ASB, and have a special look on what? That this Fy is what? Because sometimes they might give Fy of the stirrups different from the longitudinal steel. Okay. Very nice spacing. Now I want to see from the code what code tells. Let us go to the code then. Let us go to the code. Okay. Let us see what the code speaks of this. So for that we will go to IS 456. For that I will go to IS 456. Okay. I will go to IS 456. Yeah. You can see here. First of all, limit state of collapse shear, right? Limit state of collapse shear. So IS 456 what is telling? First you find out this one, right? First you find out what? This tau v. Tau v, how what is VU by BD, right? VU by BD. So you got our VU by BD. Then what is written? You see, we have to find out tau c from where? From the table. From the table, tau c table. Now tau c table you see. Tau c table you have to see M25 because our grade was M25, right? So for M25 concrete, yes, you see, for M25 concrete, our grade of this is what you see. This is AST by BD into 100. AST by BD into 100 is what? That is PT, na? AST they have written same thing, na? So AST by BD into 100 is PT. So basically it's PT, right? So PT, you see, 0.75 and your 100. See, for 0.75 these are the values. Yes, for 1 these are the values, right? Yes, and I have to see M25, so I have to interpolate between what? 0.57 and 0.67. That's what I did, right? If you see, that's what I did, right? You see, I interpolated between what? 0.57 and 0.64. Code is very easy. Just you have to understand properly. Code is very easy. Code is very easy. Code is very easy. Code is beautiful. I love code. Okay, very nice. So we got how we are finding this spacing. Okay, and then once we got this, then we got the spacing, right? Very easily we got the spacing by using the equations of this. You see, this is the equation, right? This is written what? You see what is written here? It is written, you see, 0.87 Fy ASB D by SB VUS something is written. I'll decode this equation, okay? I'll decode this equation, and how they're finding the spacing using this equation, I'll decode it, okay? Just wait for some time. Let us go back to our, what has happened, man? Now, let us go back to our this thing, okay? अरे क्या हो रहा है? Okay, अरे मैं इसे भी तो कर सकता हूँ. Okay, हो गया. Okay, now see. Let me decode that equation which is given in the code and what questions they can ask. Okay. Now see, on the section factored shear force is coming. This is what the factored shear force, or total shear force. Factored shear force is coming. Okay. Now some part of the shear force will be taken by whom? By the concrete, that is VUC. This much will be taken by concrete, and this VUC will be what? Tau C into BD. This will be VUC. Tau C into BD is VUC. Now the rest thing will be taken by what? Steel. This is what? VUS. This is known as the design shear force. This is known as design shear force or factored shear force, VU. What is this VUS? VUS is the design shear force for stirrups. Design shear force for stirrups. For stirrups. Yes, means I can say the steel, or I can say the transverse steel, or stirrups. Now I can say that VU is equal to VUC plus VUS, na? Yes, VUC plus VUS. Now, and I can say that your VU minus VUC will be equal to VUS. Yes, for this much I have to design my stirrups. Yes. This is the force, design shear force for stirrups, VUS. VUS. Now, what has happened is that there is something known as shear capacity of stirrups. There is something known as what? Shear capacity of stirrups. And that shear capacity of stirrups is how much? That is your 0.87 Fy ASB D upon SV. This is the shear capacity of stirrups. This is the shear capacity of stirrups. Now, this is the shear capacity of stirrups, suppose CS, shear capacity of stirrups. And this is the design shear force of stirrups. Now, what has happened? The design shear force for stirrups should be less than equal to the shear capacity, na? Yes. What has happened is went to torsion. I will write down here only. Yes, this has to be less than equal to. Do I have space for this? Let me just see. Here I can write down. So your VUS, I can say VUS should be less than equal to your CS. So VUS is what? It is your VU minus VUC. Yes. What was your VU? VU, you see, tau V was what? Tau V was VU by BD, na? Can I write VU is equal to tau V into BD? And your VUC was tau C into BD. So what I can do? I can write down this whole thing as tau V minus tau C into BD, na? So I can write down this whole thing as tau V minus tau C into BD. Okay. And this can be less than equal to what? You see, 0.87 Fy. The shear capacity was what? ASB d by sb. So when this equation is written, what happens? This d get cancelled and I get this equation. Understood? Understood? I get this equation. Now what the code has written, you see, code has written that VUS actually equal to CS, because this is the, we can say less than equal to, or I can say maximum it can become CS, right? So less than equal to, right? It's less than equal to. Code has just written equal to and given us. You see, I'll go back to code now. Let us go to the code now. You see, if you see this equation, you see, this is nothing but what? Tell me, ladies and gentlemen. If you see this equation, this is nothing but what? This is VUS is equal to shear capacity of stirrups. Yes or no? Yes? Let us do some signature. This is nothing but CS, na? Yes or no? This is nothing but shear capacity of stirrups. Understood, everyone? Very easy. Now the code has not given the spacing formula, okay, but they have given this. From this we have got the spacing formula. Why I am teaching you these things? I will tell you why I am teaching you these things. There is a reason behind why I am teaching these things. Okay. The reason why I am teaching these things, I will tell you now. First thing, it helps in remembering the formula. Second thing, apart from spacing, see, spacing we got, the spacing thing was very nice, so we got our spacing by using the formula. Apart from spacing, in the examination they can ask you the next thing, okay. The next thing, Sumit Kendre, I will ignore your comment. Why? That also I will ignore to answer. Focus on what is going on here. Always students have this common problem. When they are studying X, they are worrying about Y. When you are studying shear design, put your complete focus on what is going on at that moment. Okay, understood? Okay, spacing. Okay. Next thing. Now the focus was on this, and some people are thinking, "Pata nahi kya kya soch raha hai, koi pagal ho gaya hai, kya kya soch raha hai." They will ask you the spacing. You can get the spacing, but apart from spacing, they can ask you something else also. If they ask you the shear capacity, they might ask you shear capacity, na? They might ask you shear capacity, na? Yes. So shear capacity, how you will get the shear capacity equation I told? What was the equation? 0.87 Fy ASB T by SB, right? And suppose the spacing you provided is 115 mm. Suppose the spacing you provided is 115 mm, right? So here it is 0.87. Fy was 250, by the way, right? 250 because it was mild steel. ASB is what? ASB is pi by 4 into 8 square into 2. Okay. And D by SB. I want to ask once, Praveen, have you covered all the videos of RCC from Learn with Video Lessons? Have you covered all the videos of Learn with Video Lessons of RCC? Have you covered all the videos of RCC in the Learn with Lessons? Have you covered? By this time, this is D is 450. Okay, so you didn't got the answer there. So why you are attending this class? This person is. I will leave the class here. If you speak, I will. Please somebody handle him here. This person, I am very much. I'm not. Is disturbing me. So admin, whoever is listening, please either block him or I am not going to take the class. I am closing everything. I'll sit idle till you stop commenting on this. You have attended all the things there. I have explained everything, and you have don't know. And when I am teaching you shear design, I am teaching you something. You are telling something else. And this is also a marathon where you're supposed to know all these things. I will I will not take the class till the time this person is not blocked. I will simply sit. If somebody is not listening, then it's fine. I will sit. Till the time this person is not blocked, I am not going to take the class. Always disturbing when I am teaching something else. I am not worrying. See, I don't worry. Okay, you don't tell me that I have to worry or not worry. Okay. Till the time this person is not blocked, I am not going to take the class. I am sitting. Something is going on, something else. This kind of behavior you do go and do in some other people's classes. Please don't do in my class at least. I am not going to entertain these things. I will not tell you put heart in the comment section. All those things I don't do. Okay, I don't like these things. I am not that cadre of teachers which you are habituated from which platform I don't know. Okay, I am not here to create revolution, rotation. Okay, ultra rotation. So if you want to focus on what I am teaching and you don't to, after making you understand so much also you are still in that nonsense. What is tensile load, man? What is tensile load? Huh? It's a beam. When a transverse load acts, the beam bends, right? There's nothing called tensile loads. There's nothing called tensile loads. Okay, it's a transverse load because this is the longitudinal direction, this is the lateral direction. This particular concept I have explained in the learned with video lessons initial part. I have explained in details. But obviously you are not concerned about that because you are preparing for ESC. You are very enlightened person. So other students I'll explain. Okay. There is no significance in this, but this person will tell later that सर को आता नहीं था इसीलिए सर ने बताया नहीं. बताता हूँ. Longitudinal direction and this is lateral direction. First of all, your question is wrong. There is nothing called tensile load. So this is a transverse load. So transverse load creates what? Bending. Yes, and due to this bending, this part is under compression. Yes, this part is under compression. Yes, and this part is under tension, right? This part is under tension, right? So load is not tensile, the load is transverse, and I've explained. Obviously you will don't pay attention to this. So this is tension. Now what happens? The concrete is strong in compression and therefore it can take the compression. Yes, but it will crack at bottom because the concrete is weak in tension. So therefore we provide what? The steel in the bottom or in the tension zone. Okay. So the steel is provided, the reinforcement is provided, to take the tensile stresses, okay, okay, developed tensile stresses developed due to bending. And I don't know who is monitoring this particular class. I told to block, but still it is not blocked. So that means the person who is monitoring this class has no respect for me also. Okay, so that means okay, anybody can come and do anything. Sir, you please continue the class. Very nice. I'm not going to take the class because nobody is listening to me. There is no respect. I am not going to take the class. I am really pissed off. And message first. Why they are not blocking him? No, I am thinking, I will tell, don't worry. I am teaching, don't worry, I will not go. That is just, I was just angry. Okay, okay. The question was wrong. Okay, so due to bending, what is happening? The reinforced is provided by the tensile stresses developed due to bending, and this bending is due to what? Due to transverse load. Very nicely he has covered the learn modulation. This is covered in the initial part of the video, but obviously people are not attentive. Okay, they do whatever they want. Come back to this here design. Let us come back to here design. Okay. So why I was explaining from the code, okay, that apart from the spacing, they can ask you other things also. Apart from the spacing, they can ask you other things also. Okay, like if they ask you the shear capacity, if you just run, the spacing, if you don't know this formula, then what will happen? You will commit mistakes. So tell me how much you are getting this shear capacity. See, this will be in Newton. You have to divide by 10 to the power 3 to get in kilonewton. Tell me what is you are getting, how much you are getting, tell me. $85.56. Okay, you have to take 100, 115. Suppose spacing I have taken 115, then you have to take spacing 115. 85.5. Okay, so in the examination they can ask you spacing. So spacing they ask, we know how to find out. But apart from spacing in the GATE examination, they can ask you other things also. They will just give the spacing and they will ask you find out the shear capacity. So you should know this formula, very important, right? Next they can ask is what? Design shear force for stirrups. Next they can ask is what? Design shear force for stirrups. Okay, and design shear force for stirrups is what? VUS. How to find out VUS? Very easy. That is VU minus tau C into BD. Right? Now VU how much we got? That was 150 kilonewton. Tau C we got how much? If you remember, we got 5.594. Okay. B is 250. D is 450. Okay. And this is what? Divided by 10 to the power 3. Because I have to convert into kilonewton. So how much are getting this VUS? Tell me. How much are getting this VUS? The design shear force for stirrups. How much are getting? Tell me. Don't worry, I will continue the class. I was just showing my anger. 83.18. Okay, sometimes sometimes little bit of scolding is required to tighten the nuts. Yes, sometimes little bit seriousness is required. Okay, and I think now you have become a little more serious, right? Yes. So apart from the spacing of stirrups, they might ask you shear capacity. You can find it this way. Yes. Or they ask you the design shear force for stirrups. Then also you can find out this way. And you can see that the design shear force for stirrups is less than what? Less than equal to the CS. Yes. Because you see spacing how much you got. Your spacing you got 118 point something, right? How much you got? Spacing how much you got? Spacing you got 118.77, right? See, if you take that 118.77 na, 118.77 na, then what will happen, you know? Then you will get, you know, VUS is equal to CS. Yes, you will get this. But I took spacing less than that, and therefore what happened? For spacing is equal to 115 less than that, you will get the VUS less than the CS, which is good. Understood? The design shear force should be less than the capacity, right? And therefore we take spacing less. Because you see, when the spacing is taken less, then the shear capacity will increase, na? Understood, everybody? All this logic everybody understood or not? Tell me. All this logic you understood or not? All this logic you understood or not? Yes. Now in this they can ask you the maximum spacing also. They can ask you the maximum spacing also. If they ask you the maximum spacing, what is the formula for maximum spacing? The formula for maximum spacing is, equal to minimum of 0.75D and your 300. 0.75D and 300. Right? Now tell me, 0.75D and 300. D was how much? D was 450. So 0.75 of that is how much? Tell me. How much is that? 0.75 of 450 is how much? How much is this? Tell me. Thank you, admin, for writing good comments. Okay, this is 337. Okay, so from here the maximum spacing you will get how much? 300 mm. Because you see, out of these two, the minimum one is 300. So maximum spacing is 300, and you have taken how much? 115. So everything is fine. So all these questions they can ask from what? Shear design. Now everybody knows what they will ask from shear design, right? From flexor design we have seen. From shear design also we saw. Very good. Good students. Okay. Very good students. I am very happy with the class because majority of the class is very serious. No, we don't have to take three. Maximum spacing is this. So let us revise whatever we have studied till now. Let us revise everything. First of all, in single reinforced beam, they can ask you what? They can ask you XU limiting. You will see so many things we have studied. Then how to find out XU we studied. How to find out MOR we studied. How to find out MOR limiting we studied. How to find out AST limiting we studied. How to find out PT limiting we studied. How to find out PT minimum we studied. How to find out AST minimum you studied. Yes. Then how to find out AST maximum we studied. Right. Then also we studied what? Assumption change questions. Right. Assumption change questions. Also some questions on like how many bars have to provided to make it under reinforced, over reinforced, those kind of questions we solved. Then in this anything is remaining? No, I think everything is covered. Yes. If there's more, these are the all important things which you have covered in the single reinforced beam, maximum chance of being asked in the examination. Now coming to shear design, what I told, most of us they think that spacing I have covered in details how to solve, no problem. Apart from spacing, they can ask you what? The shear capacity, or they can ask you what? The design shear force for your stirrups. Okay, this thing they can ask. Okay, this thing they can ask. And also they can ask you the maximum spacing. Also they can ask you what? Maximum spacing. And your spacing should be less than what? The maximum spacing. The maximum spacing is what? Minimum of 0.75D and 300. Okay, so this will be 1 mark question. If they ask you maximum spacing, 1 mark question. 1 mark question. If they ask you this is also 1 mark, because this is simply what? VU minus tau C into PD. Now this is also 1 mark question. If they ask you this also is 1 mark question, right? 0.87 FY into ASB. See, this much you remember, then you remember D by SB. D by SB. And if they ask you spacing, that will be 2 mark questions, because sometimes they might ask you what? They might use what? And you see this one is same. You see 0.87 FY ASB divided by what? This is your tau V minus tau C into B. So in this case, you have to find out the tau c na. So if tau c is not given, you have to find tau c from the table, right? How to find out table from PT versus tau c? I have already explained to you. This table will be given to you. Okay, so many things we covered, right? Let us go to torsion. Let us see that in torsion what questions can be asked. Let us go to torsion design. Now in torsion design there are many things actually, many things, but we have to see that which has the maximum probability of being asked in the examination. In torsion what happens, you see, if we have a beam like this, you know, I will tell you one thing. One thing which angers me always is that if I'm teaching X, somebody start asking why na, I feel very irritated. Because why? Because not because of my ego, or you know, it actually harms you. Yes. Suppose you are studying X, your full concentration should be in X now. So you should be asking doubts from where? X only. Yes or no? Your mind should be in X. Yes. Once X is complete, and then suppose session is complete, then you can ask, you know, sir, I have doubt in this or doubt in that. So in studies also, whenever you are studying geotech, study geotech that time. That 2 hours, 3 hours, 3 hours, 4 hours, that time you just focus on that. Don't worry about anything else. After that is over, then you start worrying about other things. This concentration is required. If you are always, X is going on, you are telling Y is going on, you are thinking Z. Means what happens, you know, our mind is like, you know, हाँ ये तो हो गया. क्या होता है? We feel that okay ये तो हो गया, but ये हुआ नहीं है ना, ये नहीं हुआ है ना. So what happens? We are not focused here, and then when we study that, we forget this. Then we start worrying about this. So whenever you are studying something, put your full effort. In what? In that particular thing. Once that is over, then you're worrying about other things. Okay? Now, coming to torsion design. Now this is a beam, right? This is the beam. This is the longitudinal direction. This is what? This is the longitudinal direction. And this is the transverse direction. Or lateral direction, right? Now, we provide steel like this, na? You see, the longitudinal steel is provided like this, na? Yes or no? The longitudinal steel is provided like this, in the longitudinal direction, right? Yes. And then we have stirrups like this, you see. Stirrups will be, you know, in between stirrups will be there like this, yes or no? Sorry. Yes or no? Yes. So I can say these stirrups are what? Stirrups are actually what? They are transverse steel. They are what? Transverse steel. Now, stirrups are designed for what? Stirrups are designed for the factor shear force we just saw, na? This stirrup spacing depends on VU, na? The factor shear force, because VU by BD we find tau V, then you know spacing is what? Spacing is your 0.87 Fy ASB divided by tau V minus tau C into B. So tau V depends on VU. Yes, tau V depends on VU, and therefore I can say this stirrups or transverse steel is designed for VU. Everybody is convinced about it? Very good. Now these bars, these are known as what? Longitudinal bars. Longitudinal tensile reinforcement or longitudinal bars. Now longitudinal bars is provided for flexure. They are for what? For flexure, or I can say bending moment, or I can say for the design bending moment of MU, suppose. Design bending moment of what? MU. Okay. Yes. Yes. So I can say, if you see the cross section, therefore I see the cross section like this. Now if you cut a cross section, what will happen? You see this will be the transverse steel, stirrups will be visible. Yes. The stirrups will be visible, and then you know, then there will be this tensile steel. Sorry, what happened? Yeah. The stirrups will be visible like this. I will draw in red. It's clear actually. This is the stirrup and this is the this. Yes, see this is the stirrup, or I can say transverse steel, right? The stirrup or transverse steel, and this is what? This is your longitudinal steel. This is what? This is your longitudinal steel. Understood? Understood? Now see, this longitudinal steel is designed for what? Design bending moment, right? And transverse steel is designed for what? VU. Understood? Yes. Everybody is clear about this? So stirrups are designed for VU and your longitudinal steel is designed for what? It is for MU. Or I can say this AST, na? AST comes from MU. There is a formula actually, right? What is the formula? The formula is, they don't ask in the GATE examination, therefore I didn't discuss it. The AST is equal to 0.5 FCK by FY 1 minus root under. I didn't discuss this because normally they don't ask questions from this, therefore I didn't discuss this. MU by BD square FCK into your BD. So I can say this area of longitudinal steel, right? This area of longitudinal steel, it depends on what? The design bending moment MU. This is what? This is your design bending moment MU. This is the design bending moment MU. Or I can say factored bending moment. I can also say that word factored bending moment, because this is what? This is LSM. Now, we got our spacing of the transverse steel stirrups. We got the spacing for stirrups, right? Less than equal to what? 0.87 Fy ASB divided by what? Divided by tau V minus tau C into B. Very good, right? And here you see this tau V is what? It is VU by BD, right? Therefore I can say that the stirrup spacing or the transverse steel, it depends on VU. That is what I can say? Design shear force. I can say this as what? Design shear force, or I can say factored shear force, right? Or I can say what? Factored shear force. And this I can say is what? This I can say is what? Factored bending moment. This I can say is what? Factored bending moment. So we understood, okay, for bending moment, very good, very easy. So obviously, if the beam is there, okay, beam bends. So obviously, when beam bends, there will be bending moment and shear. So for bending moment, I am providing longitudinal steel. How I am providing? I saw. For shear force, I am providing stirrups, and how I provide? I saw. But if there is some, for some reason, there is some twisting, right? Some twisting might also occur. Chances are less, but there might be some amount of what? Torsion also. If there is some amount of torsion, then what to do? What code suggests? Code suggests is that if there is some amount of torsion, suppose that is the factor torsional moment, factor torsional moment, the code suggests that don't provide any new type of reinforcement. What you do, you increase the shear force from VU to VE. How? By adding 1.6 TU by B. If you add this one to the existing shear force, yes, VU, this is the addition, right? So what happens? The shear force increases to what? Equivalent shear force. This is what? Equivalent shear force. So increase it. If you increase this VU to VE, there will be what? Tau VE, that is equal to VE by BD. And obviously the tau VE will be greater than tau V, na? Because tau V is what? Your VU by BD. So obviously what will happen? It will be tau VE. Now I have to design for tau VE instead of what? Your tau V. That is the only change code tells. And some other changes are there. I have explained in the Learn with video lessons. I have already explained in details. But so much of details is not required. Therefore, I am not covering them in details here. I am covering that much which has highest probability of asked in the GATE examination. So, instead of doing what? Instead of what? Providing some new kind of reinforcement, just do what? Increase the shear force, and now shear design. Now shear design will be as per what? Tell me. Will be as per your VE instead of VU. Understood everyone? Instead of VU it will be for what? Instead of VU it will be for V. Simple. And code also tells that increase the bending moment also. How? To equivalent. Already MU is there due to bending. Now due to torsion increases to 1 plus capital D by B into TU by 1.7. These are empirical formulas you have to remember. There is no other way. Okay. So add this, yes, to the existing bending moment. So what will happen? Bending moment will increase. If bending moment will increase, now the longitudinal steel is designed for what? Tell me. The longitudinal AST, right? The longitudinal AST is for what? Is for your ME, not for MU. Everybody understood what happens in torsion design of beams? In torsion design of beams, okay, in torsion design of beams, we don't provide any new kind of reinforcement. We just design the beam. Instead of VU, I will design for VE, yes, and instead of MU, I design for ME, the longitudinal steel. That means what will happen? What will happen? In this equation, you see, what happens? In this equation, this MU will get replaced with ME, yes, and this will get replaced with what? Your tau with B. And some other things are also there. I am not going into those complications because not required. Right now not required. Okay. For GATE examination not required, so don't go into those such complications. Right. Now what happens? Therefore in the examination, they will ask you mostly what? To find out this VE and ME, and you know these formulas. The two formulas becomes very important. For example, if I give, you know, this was the design we already did. Okay, there were three. You see, what was the existing design was what? There was 320 mm dia bars were already there. Yes, 320 mm bars were already there, right? Now see, now what happened? This is not doubly reinforced. These are called hanger bars. These are known as what? Hanger bars. Known as what? Hanger bars. Okay, and this is the stirrup, and this is the AST. This is the AST. In singly reinforcement, they are hanger bars just to hang the stirrup. Okay, normally they are 12 mm bars. Okay. Now in this, if I ask you that torsional moment is also existing, torsional moment is, suppose I am telling suppose 10 kilonewton meter. 10 kilonewton meter. Okay, 10 kilonewton meter. Now what was VU? Remember it was 150 na? VU was 150 kilonewton. Yes, and your MU was how much? Suppose MU I am giving some value. Suppose MU is giving, I am giving the value of 150. 150. Suppose MU is 100. Suppose MU is 100. This will be given to you. Now can you find out what? This will be given in the question. Don't worry, these all things will be given in the question. Given in the question. Now to find, in the examination they will ask you what? To find out what? To find out, they can ask you first find out VE, the equivalent shear stress. This will be how much? We can find out, right? That will be equal to, see, 150 VU plus 1.6 TU. TU is what? 10. Now divide by what? Divide by the width. Width is given how much? The width was 250 mm, right? So width is 250 mm. So how much you are getting this answer? Tell me. How much you are getting this answer? Tell me. Same beam. The same beam which I have drawn from starting, same beam I am continuing. What's the answer? Tell me. How are you getting this value? $214. Very good. This will not be 250. This will be how much? 0.25. This will be 0.25. Why? You see, this is in kilonewton. Now this is in what? Kilonewton meter. This has to be in meter. Then only meter will get cancelled and final answer I'll get in kilonewton. Na? Understood? So don't commit this mistake. Many students commit this mistake. Therefore I deliberately did this. So width is in mm. I'll convert into what? Meter. So this will be what? 150 plus 16 into 10 divided by what? 0.25 meter. So 0.25 meter will give me how much? 64. Actually it will get. How much? 1.6 na. This will be getting 40. Getting how much? 214 kilonewton. Very important point. Very important point. Okay. Unit has to be meter. Then only it will get cancelled. You will get answer in kilonewton. Otherwise you will commit such mistakes. Okay. Therefore avoid this. So if they ask you VE, you can easily find out. If they ask you, you see equivalent nominal shear stress. Now what is equivalent nominal? That is tau VE, and tau VE is VE by BD. So instead of VU you will find out what? VE by BD. So first you have to get the VE. We got now 214 into the power 3 divided by what? B is 250 and D is 450. Same dimension, same beam I am continuing. So that there is no problem. How much you are getting? Tell me this value. How much you are getting? 1.9. 1.9 you will get, na? Yes, 1.9. You get more value, na? Understood? Understood? So if they ask you the equivalent shear force, this is the answer. They might ask you find out the equivalent shear stress. So first you find out the equivalent shear force and then find out the equivalent shear stress. Simple as that. Yes. And if they ask you, ladies and gentlemen, if they ask you to find out the equivalent bending moment, how will find out? Mu was 100. Then you see 1 plus, it is capital D by B. Ladies and gentlemen, please remember, this is capital D by B. Okay. So capital D by B means what? Capital D is 500, right? It is not 450. Capital D means what? Total depth. Divided by 250 and then TU. TU is how much? 10. Now divided by 1.7. How much you are getting this? Tell me. ME. ME, how much you are getting? $117.64. Okay. So in the examination, if they ask you find out the equivalent shear bending moment and equivalent shear force, you can easily find out these values, right? Understood everyone? Torsion, what most probable questions they can ask you? Everybody understood or not? Everybody understood? Okay. Now obviously more things they can ask. There are so many things in torsion also, but I am not going to that. If you want to see those things, they are available in the app. Okay. I am not covering them because I am here only covering the most important portions for the GATE examination. Obviously I cannot teach 50 hours in 5-6 hours. That's not possible. But what I am focusing is that what things are asked prominently, that we are going in details. Okay. The things which are asked prominently, because before the exams we will be focusing on the prominent things. If you want to cover more, the more things are present in the app. Okay, let's go to next thing. The next thing is torsion is over. So many things we have seen, right, till now. Yes, so many things we have seen. We saw flexor. Yes, we saw the most important things for flexor. Actually flexor is most important actually. Therefore I covered that in details actually, whatever single reinforced beam, everything. Okay. And then shear also I taught whatever important things are there. Then important things of torsion also we covered. Okay. The next thing is compression, means columns. Okay. The next thing is compression, axial compression, right? Axial compression. Now I think that you might have tired, so we'll take a break, but not a long break. Huh? Not to take a long break. We'll not take long break. So we'll meet at break time. So let us meet at 1:25, no? 1:25 p.m. Now tell me, ladies and gentlemen, now I will ask you, any doubt from these portions? Now ask me any doubt from these portions. I will clarify your doubts from this portion and then we will take the break. Let us make it 1:30. Any doubt from this portion, from these three topics, and then we will take the break. Any doubt from whatever is taught till now? Any doubt? Now I am open for doubts. Any doubts? Please ask. Please feel free to ask. I will not get angry because I am asking you only from these three things. Don't ask me from compression because I will teach in a later. No? From these three things, any doubt you have for your GATE examination? Any doubt you have for your GATE examination from shear, from flexor and torsion? Any doubt? Please ask. Feel free to ask. No problems because now doubt time. Clear? I'll wait for 1 minute. Then we will 1 minute, and if no doubt comes, then I will move on. No doubt. Can tau b be less than tau c? Yeah. If tau b is less than tau c, we go for minimum shear reinforcement. Okay. If tau b is coming less than tau c, we go for minimum shear reinforcement. Yes. Okay. I'll answer. Minimum shear reinforcement, and minimum shear reinforcement, what you will do? Just in the formula 0.87 Fy ASB, replace tau b minus tau c with 0.4. That's it. That's it. That's it. Understood? Yes. Is MSQ coming in the exam? Yeah, MSQ can come. See now you see, I explained, I taught you how to find out. See, like I taught you how to find out. Suppose we discuss these things, right? We discuss these things. See, you discuss these things, right? These things. And the examinations, they can ask you XU limiting, XU MOR. Three things they can ask now in 3 options. Yes or no? It becomes MSQ. They can ask you 3 options or 4 options. One option is XU limiting, one is XU, one is AST limiting, one is PT limiting. It becomes an MSQ, right? Understood? They can ask you like this. Okay. More questions? So in spacing of syllabus, when we can check that formula, with that formula, when tau b minus tau c is less than 0.4, you can check that. Okay. When tau b minus tau c is less than 0.4, you are getting less than 0.4, then you can go for minimum shear reinforcement. Okay. Okay. If there is less than 0.4. Next question is, sir, can we neglect assumption change questions? Yeah. See, if you have time, then you can go for assumption change. But first of all, cover the straightforward things. Like therefore, I first covered all the straightforward things, and then I told some things about assumption changes. So assumption changes, if you are finding very difficult, first to cover all the basic things, which I will be covering obviously in the class. Okay, straightforward things. And assumption change they can ask. I will not say that they will not ask. I can say that the chances are very less, but certainly they can ask. Okay, so you should be ready. So basic things I have already covered, right? Basic assumption change I told, na, XU limiting, how they will ask. I told only, yes. Okay, anything else? No labs in your head. Very good. So now some student asked me about MSQ. So in MSQ also, if you want to see the type of MSQ, na, I have taken one session. Okay, ladies and gentlemen, I will just tell some things and then I will take the break. But I'll extend the break. Don't worry. I'll extend the break to 12:35, 1:35. See, I have already taught you many things. If you want to practice more questions, I have saw these 3 videos you can do. This is 30 expected questions of RCC, I have solved many questions there. Then formula memory test, I have solved questions. Yes. So here I have solved around 15 questions and rest 15 homework. And this is what MSQs I also have solved MSQs from RCC. You can attend that session. Okay, that is available in the channel. And formula also I have done. Apart from that, I have taken these 100 questions, if you remember. 100 MSQs, small straightforward questions. 100 MCQs, sorry, 100 MCQs I have already taken. So you can cover this video also after this lecture is over. Okay, you can cover this video also, this 100 MCQs for all examinations. For all examinations RCC I have taken, and you can cover these 3 lectures also. Only you can solve questions, practice. You want practice questions, na? So these thing questions. And then also I have taken 10 numericals on singly reinforced beam. Okay, 10 top 10 numericals on singly reinforced beam. So all these videos are available in the channel. So you can Google it out or you can search in the channel. You can get these lectures. So after the lecture is over, you can practice questions. That will be sufficient for a GATE examination. So let us go to now break time. Okay, break time. Okay, so we'll just change this to. अरे क्या हो गया भाई? रुक जा भाई. अरे column design is telling मेरे को पढ़ाओ. रुक जा अरे भाई तू रुक ठंड पाले. Okay. This will be, I will extend it to 1:35. 20 minutes break will take, not much. Okay. 20 minutes break. जल्दी जल्दी खा के आ जाओ भाई. हाँ, क्या इतना क्या खा रहे हो? Okay. Then we'll see column design. Then we'll see development length, and then we'll be seeing pre-stress concrete also. Okay, so we are back. Ladies and gentlemen, if you are able to see me, please tell yes sir, so that we can continue the class. Okay, means I'm just speaking in little fake accent. Oh no, yeah. Okay, welcome everyone. That was a short break. The break is over, so if you are able to see me, please write in the comment section yes. If you are unable to see me, then refresh the page. But if you are unable to see me, then how you are hearing me? Okay. Okay, very good. We will go to column design now. Okay. Solve some questions on column design. Okay. Column design, column. So in column design, let's wait for other students to join in. Okay, so how are you all? Everyone is doing fine. Everyone is happy. Preparation is going on nicely. Life is good. Okay. Don't worry, study. And don't study more, study optimum. Don't do PhD. So around, I think, around 20 days are left for GATE, 20 nahi. The 25, 26, 27 days are left for GATE, which is a substantial good amount of time if you have studied before. So if you have studied before, time is to revise now. So take benefit of the marathon sessions conducted in the BYJU'S Exam Prep official YouTube channel. Okay, for civil and mechanical. So a lot of sessions. So today I am taking RCC, but other teachers have also taken. So like geotech is taken, environment is taken, transportation is taken, fluid mechanics is taken, right? Such analysis is taken. That was taken in 2 parts. Yes. And then we have steel also covered, hydrology irrigation, right? So a lot of marathons has been conducted. So students who want to revise, they can attend the marathons. Okay. And today I am solving questions from your RCC, and then later on tomorrow I will be focusing on building metal and CPM also. Let us start the session column design. In column design, you see the column design is actually limit state of compression. The column design is limit state of what? Compression. Yes, compression. And this is what? Axial compression. This is what? Axial compression. How? Because if you see a column, okay, if you see a column, yes, if you see a column, yes, the load is acting like this. The load is acting like this. Yes, it is what? It is a longitudinal direction. See, bending was due to transverse load. This is what? Longitudinal load. This is what? Longitudinal load. Okay, this is what? Longitudinal load. And aptitude is also conducted. Yes, engineering mathematics I just informed about. Engineering mathematics, yes, that is been taken by Rakesh sir and Ankit sir on the app. So please attend those sessions also. All sessions are important. Okay, coming back to longitudinal load. So this is what? Axial compression. So what they will ask you? This is PU. Means what? PU is factored axial load. This is what? Factored axial load. Factored axial load. Okay, factored axial load. Now, this is also the ultimate load capacity of the, this also known as what? The ultimate load capacity of column. Load capacity of column. Okay, very good. Now how to find? It's very easy. It's a load. It's a load. So load is what? Load is actually equal to the stress in concrete into area of concrete. Yes. Plus stress in steel into area of steel. Stress of steel into area of steel. Very good, very nice. Now, if you see a column cross section, the cross section is a rectangular column. So rectangular column. It can be circular also. It's a rectangular column. Suppose. Then what will happen here? You see, there will be the tie bars like this, and there will be. Suppose I am not drawing the tie bar. Let me just draw the longitudinal steel. The steel will be in this direction, right? Longitudinal steel, there will be bars like this. There might be 6 bars, 4 bars, what is depending upon the load and all. Okay. Suppose this is the longitudinal steel. The longitudinal steel is AS. Now you see the concrete area will be how much? It will be the total area, gross area minus what? The area of steel. Yes. And the stress in concrete is considered as 0.45 FCK and the stress in steel is considered as 0.75 FY. But this is for what? This is for a pure axial concentric load. This is for what? This is for pure axial concentric load. If they use the word pure axial concentric load, then only you are going to use this formula. Everybody understood? So the load capacity PU, the load capacity PU is equal to 0.45 FCK into gross area minus steel area plus your 0.75 Fy into steel area. This is the formula only valid for what? Only valid for pure axial. Pure axial means what? The loads act at the centroid, right? Pure axial concentric load. Pure axial concentric load. Okay. Now in reality what happens? In reality obviously the load is not going to act exactly at the center. It's not possible, right? Exactly at the center it will not act. So they mention this, so we'll use this formula, no problem. But they don't mention it. That means what? That means we have to see what the practical conditions. So as per practical conditions and for short columns, short column means what? The slenderness ratio is how much? Your L effective by least lateral dimension. What is this least lateral dimension? Suppose we have a rectangular column. This is the width, this is the depth suppose. See actually this is not width depth, we can say two dimensions B and D. So this least lateral dimension is what? Minimum of B and D. This is what? This is your least lateral dimension. This is what? Least lateral dimension. And L effective we can easily find out. L effective, if you see, remember steel structures I have explained L effective. In the marathon of steel structure I explained na? L effective K into L, and how to find out K for different boundary conditions I have explained in details. If you have not seen that, you can go to that part and you can see the effective length thing I have taught already. Now when the slenderness ratio is less than 12, I call that as what? Your short column. So for short column and minimum eccentricity, and the minimum eccentricity is how much? The minimum eccentricity is the maximum of two things. L is not L effective, L by 500 plus your least lateral dimension by 30. So it is the maximum of this this value, and your another value is 20 mm. So this is the minimum eccentricity. This is the minimum eccentricity. So for a minimum eccentricity of this, see eccentricity means what? It is not concentric loading, it is axial. See if a load is acting and it is axial, but it is a minimum eccentricity, means it's not concentric. It is only what? Axial load. I can say this is what? Axial load. So obviously it is not what? It is not a pure axial concentric load. It is just axial load. It is having some eccentricity, minimum eccentricity of this much. Okay. For these two conditions, the code tells that we have to reduce. We have to reduce what? We have to reduce the strength by how much? By 10%. I can say 0.9 times. So when I take 0.9 times of the original equation, you see 0.45 FCK Ag minus As plus 0.67 Fy into As. When you take this, what happens? Then you get this answer. How much you are getting? You can see. You will get 0.405. Cold takes that as 0.4 FCK. Okay. Then Ag minus As. Yes. Plus 0.67 Fy into As. So you are going to use this equation only for all the questions. Only you will use the equation 0.45. When you will use the original equation 0.45? Only when they mention the words what? Pure axial. Only when they mention the words pure axial concentric load, you will use 0.45. Yes. If they don't mention that, they are mentioning only axial load, or they're writing axial load for minimum eccentricity, such kind of words, you are going to use this equation. Everybody is clear which equation to which you use when? Everybody is clear which equation to use when? Clear? No doubt about it now? Okay, let us see code, what code tells. Let us go to code then. Let us see what code tells. Let us go to code now. Okay, let us see some code things. If you go to code, see compression members, what code tells. Let us go to code. अरे बाबा कोड कहाँ गया? कोड पागल हो, कोड चला गया. कोड को बुलाते हैं. कोड आओ. बुलाएगा, आएगा. टेंशन मत लो. Yeah, code came. See what code tells. Let us see. Code tells, you see here code is telling, oh yeah, increase the size. Yeah, you see the members shall be designed by, is it visible? Yes, visible. The members shall be designed by considering the assumptions given in 39.1 and minimum eccentricity. Yes, minimum eccentricity. Yes, and the minimum eccentricity doesn't exceed 0.05 of the lateral dimension. I'll explain this when that is done. I will explain this already. Then it is designed by the following equation. You can see 0.4 FCK, and then ASC. It is written basically what? That is the compression steel. ASC, or I can write on AS also, same thing, right? So this is the equation we will use. Yes, this is the equation we will use. Yes, and then when we see the minimum eccentricity, what is written? You see, in accordance with 25.4. You see what is written about minimum eccentricity? In accordance with 25.4. Let us go to 25.4. Let us go to 25.4. When we go to 25.4, all columns shall be designed for a minimum eccentricity equal to how much? Not the effective length. It is what? Unsupported length divided by 500 plus lateral dimension divided by 30, subjected to a minimum of what? 20. Means what? Either it will at least 20 or more than 20. Yes. So what I will do? So therefore what I will do? You see, therefore I told this now. Therefore you see, subjected to minimum of 20 means what? You see, now this is the equation I explained now. So if it is getting 20, if you are getting 27, suppose you are getting 27, then fine, because it is more than 20. If you are getting 19, then how much you will take? You will take 20 na, because it is written writing what? Minimum of 20. So maximum of these two values. Everybody is clear? Everybody is clear about minimum eccentricity? What, see, code write some different language many times. You have to understand what code is telling. Everybody is clear what code is trying to tell here? Minimum eccentricity, yes. Minimum eccentricity, yes. And as I told that the column design formula to be used is this one only. The formula we'll use is this one only, 0.4 FCK. 0.45 FCK only we will use when it is given pure axial concentric load. Otherwise we are not going to use that equation. Everybody is clear? Very good. Now coming to your thing. So let us solve a question. Let us solve a question to understand this further. Solve a question further. Let us insert a rectangular beam. Okay. I insert a rectangular beam. Okay. Let us solve this question. Now suppose I am telling that this not beam, sorry, column. Suppose this is 450 mm. This is no effective depth here concept. There are two dimensions like this. And I am telling that suppose the unsupported length is 3.5 meter. And suppose I am telling that one end is fixed, other free, other pinned. Tell me in this case what will be K? Tell me as per IS code. What is K H per IS code? I have explained in steel structures. What is the K H per IS code? Tell me. in steel structure, because that is applicable for steel and column both, steel and RCC both. What is the value of K? One end is fixed, one end is pinned. 0.8, very good, it is 0.8. Theoretically it is 0.707, from code it is 0.8. So there might be an MSQ question also, right? It's finding out what? Finding out the slenderness ratio. So slenderness ratio is how much? L effective by least lateral dimension. Least lateral dimension is how much here? Let me make it 600. Least lateral dimension is how much here? Tell me. The least lateral dimension is 450, na? See, it is not width. See, this is just two dimension, capital B and D. And least of this is how much? 450. So least lateral dimension. So if I want to find out, it will be what? 3500 into 0.8 divided by what? B is how much? B is 450. How much are you getting this slenderness ratio? So in the examination, if they ask you the slenderness ratio of this RCC column, yes, they might ask you MSQ also, na? They might ask you many things in the same question. So what's the slenderness ratio you're getting? Tell me. What's the slenderness ratio you're getting? Tell me. What is the slenderness ratio you're getting in this? Tell me. आराम से पढ़ो, आराम से, कोई हड़बड़ी नहीं है, पढ़ो. Six point 6.22. And this is less than 12. That means what? It is a short column. They might ask you it is a short column or long column, right? They might ask you it is a short column or long column. That you can check by what? Slenderness ratio is less than 12 or not. You can form a standard question, right? Yes, standard question. Very nice. So this thing we saw. Very nice we saw. Beautiful. Everything is fine. Now the next thing is, if I am telling you that it is M25 concrete, I am telling you it's M25 concrete, and suppose Fe415 steel is there. Okay. Yes, steel is there. So now you have to find out the area of steel. You have to find out the area of steel. Okay. If the factored load is given as 2700 kilonewton. The factored load is given to us. This much load you have to carry. So this I will equate with what? This I will equate with your 0.4. Nothing is mentioned, mean go for 0.4 only. 0.4 FCK into gross area minus steel area plus 0.67 Fy into steel area. So what I can do, this will become 2700. It is in kilonewton and convert into Newton, because both sides should be Newton. And this is equal to, I can say 0.4 FCK is how much? 25. Gross area will be how much? It will be 450 into 600, right? Minus the area of steel plus, I can say 0.67 Fy into what? Area of steel. So from here I have to find out the area of steel, right? Find out the area of steel. What I can do is I can divide 10 to the power 3 both sides actually. That will be very less. Let it be this like this. So I can say this is 2.7 into power 6. And this will be equal to actually 450 into 600 into 0.4 into 25 divided by 10 to the power 6. 2.7. Oh! Some problem happened. Let me make it 3000. Some problem happened here. To make it 3000, that is better. It will become 0 then. Give me the AS, area of steel. $1078.94. I am getting this value. Others, please tell. Please enlighten me. 119. How? Oh, yeah. You'll get more. You'll get more. You'll get more. Let me increase the load actually. Let me increase the load. Let me make it 4,000. Let me make it 4,000 kilonewton. Let me make it 4,000 kilonewton. I'll increase it. Let us increase it. 400,000. I did some mistake with the calculations. Can you just check? I have no, I have correct. And now tell me the area of steel now. Increase the load actually. This sounds more logical. 4849. Are you getting this area of steel? Very good. Clear? So if they give you the load and other details, they're asking you the area of steel. This is the way you are going to find out the area of steel. Very standard question which they can ask in the GATE exam, and you can see it's a one-line question. You know this equation, just push, and rest is what? Simple calculations. Rest is simple calculations. Okay, that one thing. Yeah. Now if I am providing 28 mm bars, then how many bars are required? Tell me. 28 mm bars I am providing. Then tell me what's the number of bars required. Find out this. Now, for how many bars are required? Tell me. If I am providing 28 mm bars, then how many number of bars required? Tell me. Eight bars, because I will getting 7.88 actually. You will be getting 7.88. You have to take how much? Next integer, 8 bars. Understood? Understood? So in this column design, what they can give? They will give you all the data, like you know the cross section and all. Yes, the cross section and all, and they can ask you what? Find out the area of steel if they have given the load. Okay, very good. Now see, they ask you area of steel, we can find area of steel. If they ask you number of bars, we can find number of bars if the diameter is given. Very good. Now they can ask you the minimum eccentricity. Minimum eccentricity will be how much? Remember, this will be L by 500, not L effective. Somewhere I have given L effective, that is wrong one actually. In some lectures I have told L effective, that is wrong. That's not L effective, it's L actually. Okay. So either this or this. Let us see. What is the minimum eccentricity? They can ask you a question. So L is 3500 divided by 500 plus width was how much? No, not width, B, least lateral dimension was 450 by 30. This is 15 and this is 7. I am getting 22 now. You have to take the maximum of these two, ladies and gentlemen. You have to take the maximum of these two. So it is how much? We'll get the minimum eccentricity as how much? It is 22 mm. And you see this minimum eccentricity should be less than equal to what? 0.05 times of the least lateral dimension. So 0.005 of least lateral dimension will be how much? Tell me. You see it will be how much? This is to 450 na? 0.05 into 450. You are getting how much? 22.5 mm. Yes, that means that equation was used was correct, right? Yes. So understood? See, they might not ask you this thing. They might see what things they can ask. They can ask you slenderness ratio. How to find out? I told. They might give what? Give the load carrying capacity and ask what? And find area of steel. How to find out area of steel? We just saw, right? Then once you get the area of steel, they might ask you the number of bars if the diameter is given, right? Or they can ask you minimum eccentricity. Either they can ask you any of this or they can ask you an MSQ also, na? Then ask you an MSQ also. So anything they ask, I am ready. Anything they ask, we are ready, right? Anything they ask, we are ready for that. Very nice. Beautiful. Now see, ladies and gentlemen. Now see, ladies and gentlemen. Okay. What else they can ask from column design? That is important. What else they can ask from column design? The next thing they can ask from column design is that they might give you the area of steel. They might give you the area of steel and they can ask you what? To find out the load carrying capacity. Yes, they can ask. Let us solve one question. Suppose a circular column is given, right? Circular column is given, and suppose circular column has a diameter of, I have formed the question actually, different question, I have formed my own questions. Suppose this is 600 mm, okay, this is 600 mm. Now, it is given that the circular column has helical reinforcement. The circular column has what? Helical reinforcement. MCEN data is given, it is M25 concrete and Fe415 steel is there. And it is written that we are providing steel. How much? Steel, longitudinal steel is, it is written that longitudinal steel, the longitudinal steel is 1.5 times of minimum steel. 1.5 times of minimum steel. 1.5 times of minimum steel. So when they write this 1.5 times of minimum steel, so what is the tell me what is the minimum steel percentage? What is the minimum steel percentage? Tell me. What is the minimum steel percentage in your RCC columns? What is the minimum steel percentage? What is the minimum steel percentage? 0.8%. It is 0.8%. 0.8. That means what? This is 1.2% of gross area, na? Yes or no? That means this is 1.2% of gross area, because minimum steel is 0.8 times. So 0.8 times into 1.5 is 1.2 times of gross area. So 1.2% of gross area means what? 1 by 1.2 100 into pi by 4 into 600 square, right? Yes or no? So tell me how much you're getting this area of steel. Area of longitudinal steel, how much you're getting? They might frame questions like this. So what is the area of longitudinal steel you're getting? Tell me. How much you're getting? Tell me. Yes, I'm getting 3393 I can take approximately, right? I can take 33939292 approximately. You can take an approximation, no worry. This much I am getting the area of steel. Now I can find out the load carrying capacity. Now I can easily find out the load carrying capacity. Okay, development length came. Here I will just find out. Okay. The load carrying capacity will be how much? The load carrying capacity will be whatever equation we get, since it is given helical reinforcement. Since it is given what? Helical reinforcement, I will increase the load carrying capacity by 5%. This will be how much? 1.05 of the original equation. 1 second. I'll take one extra slide. What I will do is, you see, the load carrying capacity will be 1.05 times of the 5% increase of the original equation. Means what? 0.4 FCK, then the gross area minus the area of steel plus 0.67 Fy into area of steel. So everything we know, yes, everything we know. Can we find out the load carrying capacity? Yes. This will be equal to, don't forget this, because this is for what? This is for helical reinforcement. I will explain, don't worry. If you know already, very good. It is 1.05 into what? Into 0.4 times of FCK. FCK is how much? FCK is 25. Gross area is how much? Gross area is your total one. How much total one? 450 into, it's a circular section, na? So pi by 4 into 600 square minus what? Minus or area of steel. Area of steel is how much? We got how much? 3392, na? Yes. Then plus 0.67. Fy is 415. And this is how much? This is also 3392. And this everything will get in Newton, so I'll divide it into per 3 to get in kilonewton. You see, one line question, but you have to apply the concepts properly. Yes, you have to apply the concepts properly. Tell me the answer now. Always increase. When helical is given, increase by 5%. Increase PU by 5%. Increase PU by 5% means what? Indirectly multiply by 1.05, right? How much are you getting? What is the load? 3923, okay? Getting 3923, almost, let us take 23924 we can take, right? 24 almost we can take kilonewton. And obviously they will give you a range, so no need to worry. No need to worry. They will give you a range, easily find. Yes, easily find. So here I will summarize the column design. What the prominent things they can ask is, the prominent thing they can ask is from column design is that they will ask you find out PU. The equation is this, okay? So PU is equal to 0.45 equation I will use when it is what? When it is your pure axial. Otherwise I am going to use this equation. I am going to use this equation, right? And this is for lateral ties. Lateral ties means what? You see, suppose these are the longitudinal bars. Longitudinal bars. So if the longitudinal bars are joined by lateral ties. Lateral ties means what? Like this, you see. Lateral ties. Like this, then like this, then like this. This is all lateral ties. This is all lateral ties. And this equation is applicable for lateral ties. But if there is helical reinforcement, means what? Suppose the ties means like this it is done. Understood? This is what? This is helical. This is what? Helical reinforcement. So when helical reinforcement is there, what you will do? Same equation, what you will do? Just multiply 1.05. Same equation multiply what? 1.05. And apart from this load carrying capacity, they can ask you what? They can ask you your minimum eccentricity. How to find out? I just told. They might ask you to find out slenderness ratio. That also I told. Okay, very good. Now, ladies and gentlemen, as I told, they can give what? They will give you area of steel. They will ask you PU, like we solved a question now. Or they might give you the PU and they'll ask you what? Area of steel. Same thing, right? Same equation. Sorry, same equation. Just one thing is given, the other thing is asked. We solve two questions. Understood, everyone? From column design, any doubt? What type of question they will ask? No doubt. Let us go to development length. Let us go to what? Development length. Okay. Now development length, I have already taken one video. You can see that video. Okay. Now one video is there. Okay. I have taken a short video. Okay. That is the right formula. What is the right formula for finding development length? Okay. And I have also solved many questions on development and in the upcoming classes that you can see. Yes. So I am not discussing development length in details. Okay. And many students have already, who are attending the classes, they know already I have taken many questions on development length. So right formula for development length is there available in this channel. Then just once visit that. Okay. It's a 3-minute video, but your doubts will be clear which formula to use. And for numericals, you can refer to there. Okay. Now, I can say that we have taken so many things and we are tired. So we are not going to continue the class, that is sufficient. Now thing is that how to cover pre-stressed concrete. Pre-stressed concrete, what are the important portions? I'll be discussing pre-stressed concrete. Okay. But as I told, in pre-stressed concrete, what to cover, what not to cover, that is secondary. First of all, for more practice questions, from where to practice the questions. Okay. So after this class is over, if you have already attended these sessions, very good. Or if you have not attended the sessions, what you can do? You can go and solve the questions from here, here and here. These 3 videos, your maximum questions are covered in these 3 videos. Apart from that, I have taken 100 MSQs. Okay, I'll request everyone to cover these 100 MSQs. If you cover this 100 MSQ, most of the small questions I have covered. Small questions from your RCC is covered. Okay. Now coming to PSC, this pre-stressed concrete. Okay, I'll request you that you can visit the app once. I'll explain you from the app. Okay, from the app how to see BYJU'S Exam Prep app. Okay, so if you go to BYJU'S Exam Prep app, okay, स्टील मैराथन पीडीएफ कहाँ से मिलेगा? अरे वो जो तुम्हारा सेशन है ना, उसमें you go to the description. In description you will get the PDF. Okay. So in BYJU'S Exam Prep app, okay, if you go to the app, okay, you have to go to the exam category. Okay, you have to go to exam category. You see, GATE Civil. Okay, if you go there, okay, when you go there, GATE. Okay, skip. Okay. Okay, home. Why it is not coming? I have to log in, Okay, I have to log in. Login with email. I forgot. Logged in. Very good. Now if you go to home, okay, if you go to home, okay, there are many things, okay. The live classes, here you go to learn with video lessons, okay. Here you go to design of concrete structures. You can see so many lectures are there, okay. So many lectures are there, okay. Here you can go to where it went. Learn with video lessons. Video plays in mobile only. I am showing that where you can find. So download the app, okay. Download the app from Play Store. You can see that here so many lectures are there, so many videos are there, okay. So I have taught strength of material, concrete structures, fluid mechanics, geotech, then open channel flow, environmental engineering, and other teachers have also taught very nice lectures from other teachers also. So when you go to this design of concrete structures, you see different topics are there. If you want to cover working stress method, in 3 videos I have covered all the important things for working stress method as far as GATE is concerned. Yes. Now coming to your pre-stressed concrete. In pre-stressed concrete, okay, all these lectures are there. You see nicely, all the lectures are there. You see, okay. Here you see losses are also there. Pre-stress losses, elastic shortening loss, friction loss, slip loss, creep and shrinkage loss. Now from this, what are the important videos I will tell you, which important videos you have to cover, okay. You can directly go to this numericals on stress analysis, this 1 and 2 videos, okay. These 2 videos you can cover. I'll request that you cover these 2 videos. Which one? Numericals on stress analysis, these 2 videos. Then load balancing method 1 and 2 you can cover. If you want to leave pressure line concept, your choice, okay. I'm telling you the important things. These 4 videos are very important. Which one? Stress analysis numericals, these 2 numericals, and these 2 load balancing, these 2. These 4 videos, if you cover, you will be maximum chances that question will ask from these 4 videos. Other things I also have explained, secant zone, deflection, pressure. I've also explained, but if you have no time, then at least cover these 4 videos. No need to see these videos, not required. Directly go to these 4 videos. All your stress analysis will be complete. Then in losses, you can cover elastic shortening loss part 1, 2, 3, okay, friction loss, slip loss, creep and shrinkage loss. And some additional practice questions are also there in numericals. If you want to solve, you can solve. So these lectures, if you cover, your losses is done. You see 1, 2, 3. And in this 1, 2, 3 also, if you want to skip 3, that is fine, because in the 3, I have solved little complicated questions. Okay. So 1, 2, 3. So 1, 2, friction, slip loss, flexion loss, creep and shrinkage loss, numericals. Okay. And I am not teaching beyond this because as per me, after 4 hours, mind don't work. My mind is not working. After 4 hours, my mind don't work. I need break, and any normal human being need break. So my suggestion will be, we have covered very important topics. Only pre-stress is remaining, and pre-stress you can complete from where? From this particular app. This will be available in the app. In the website, if you open, it will not open. So you see elastic shortening 1, 2 if you cover, friction loss. See, only 30 minutes everything is covered. You can play in 1.5x also. You can play in 2x also. So you'll complete in 20 minutes. Then sleep loss 20 minutes you can cover in what? See, I can teach now. Thing is that I can teach now, but after 4 hours mind don't work. Especially in when we are sitting in front of computer and artificial lights are there. So after 4 hours my mind don't work. Okay. So till the end, if I teach, the quality of delivery will not be that good. Okay. So therefore I don't want to spoil the quality of delivery. So whatever I have taught, that is already there. So please cover these things. Understood from where to cover? Like in steel also, I guided you that what to cover, right? So similarly, here also I am guiding you. I will just tell you here. Okay, you can see this pre-stress losses. Okay. In pre-stress losses, you can go to the app. You can cover this elastic shortening loss, these two, friction loss, this and this, sufficient. If don't not need to do other these 5 videos if you do, your pre-stress losses will be there. And as I told, numericals on stress analysis. Okay, more 4 videos are there. Numericals on stress analysis. This part 1 and part 2. So these 2 also you can cover. And then I have told load balancing method. Okay, my mind is not working after 4 hours. My mind don't work. I need 1-2 hours break, and then no need of you can study yourself. Already it is given there. Okay. So these 4 videos, if you these 4 videos, okay, these 4 videos, and only questions, questions. And here also you see these are 30 minutes, 20 minutes. This is 13 minutes, like this is there. Okay. So if you cover these videos, your pre-stress losses and this pre-stress will be covered for you. Okay. Pre-stress will be covered for you. And as I told, your development, 1 3-minute video I have taken, that is sufficient. And also I have solved development length questions in these 3 videos. Also I have solved development length questions in these 100 MSQs. 100 MSQs, so many questions are there. Thank you very much. Wonderful. So we revised so many things. Hope you enjoyed the session. So today evening 7:30 we have a very important session by Ashutosh Sir. So please attend this session at 7:30. Please don't forget. And ladies and gentlemen, I'll request all the students that please, this is must. This is not option. I'm not giving you to option. I'm not giving option. Okay. Okay, I am telling you no option. It is must do. Okay, if you have covered, not covered, whatever is the condition of your mathematics, must do. 21st of January, 22nd of January. Okay, keep your day free because there will be marathon, and this will be on the app. Okay, this will be on the app, and a column 6%, and 21st at morning 8 AM. This is on the app. Okay, please must do session. Okay, for mathematics. And tomorrow we'll be solving some. See, building material and CPM will have around 3 to 4 marks in the GATE examination, which is quite important, right? 3 to 4 marks they will ask you CPM plus PUT, which is quite important because it is equivalent as irrigation or hydrology or something like that. Yes. So I'll request everyone tomorrow 10 AM. Again, it will be 4-hour to 5-hour session only. I will not take more than that. So it will be 4-hour session, and I will try to cover the most important. If you remember, I always try to cover the most important things before the examination, because these sessions are not designed that we will teach you everything. These sessions are designed so that the most important things are covered. The most things are covered so that you get an idea of the examination. And if you see today, we had a wonderful session. I was personally very happy with the session. If you see, we started with the single question of single reinforced beam, and I told that so many things. You see XU limiting, MOR limiting, AST limiting, PT limiting, AST minimum, AST maximum, some weirdo questions, then summarization, theoretical questions, then some other kind of questions, then assumption change question, right? And then we went into what? We went into shear design. Yes, shear design we saw many things. Then we went to torsion also. Yes, torsion also. And we saw some questions which they can ask in the GATE exams. And most importantly, we saw column also. In column also, which things are asked a lot that I have explained in details. Yes, but is it 100% syllabus? Obviously, it is not 100% syllabus. It is the portion of the syllabus of RCC which they ask a lot in the examination. Okay, which they ask a lot in examination. And if you cover, as I told, these 3 lectures, if you cover these 3 lectures, okay, and this lecture, then you will get many things. Also in the video, I think now in the smart list things are updated. I will just get through the smart list once. Let me see once. The smart list also you get all these lectures in the smart list also. If you download the app, this our channel, the description, if you go to the description, there is a smart list. There is a smart list, smart playlist. You see, Mahamarathon is there. Then many things are there. So there also you get these things. The PDF, if you want PDF, some students ask for PDF, na? So PDF you will get there. Suppose you want PDF for this most important questions. So there you go, you will see RCC, you will get the PDF also. Okay, you get the PDF also. So if you have already attended the session, you can just see the PDF, right? And also it will be done, right? The PDF is also available. I am able to download the PDF also. Yeah, very good. So PDF is also available. The students who want to directly see the PDF also, they can download the PDF from where? From this. Okay. And there I have given lot of home practice questions also. They are given lot of practice questions also in that PDF. Okay. This lecture is very important. If you go to this lecture, okay, in this PDF I have solved how many questions? I have solved 15 questions. Okay. And I've given homework 15 questions, and in that we have most probable questions with the not the solution but the answer is given, answer key is given. So please solve these questions, and if you have any doubt in not solving the questions, then ask me also. Okay, ask me also that sir I am not able to solve, but not able to solve me, show your solution, I will tell that where you are getting stuck. Okay, then that's it. Thank you very much. Wonderful session. Okay, then bye. Bye. Tomorrow we'll meet at 10 AM and we will be covering the most important portions of building material and construction planning management. Thank you very much. Bye bye.